right, so welcome everyone. Really excited to start this forum, the Spinal Cord Injury BC Neuromodulation Forum. We are really excited about all the topics that we're going to be sharing with you today. So yes, this is day one. Today's agenda. So right now we're doing the welcome and housekeeping. I'm going to pass it over to John Chernesky. So full disclosure, I am not an expert on neuromodulation, but John Chernesky from Praxis is. So I called him in here to kind of be the host. So you'll be seeing his face more than you will see mine. We'll be moving on to the PLEX panel discussion. We'll take a short little break. Then we'll talk to Rahul about neuromodulation and cardiovascular function in SCI, and going from animal to human studies. Then Dr. K and Stacy Elliott will be joining us to talk about restoration of autonomic functions. And we'll have a Q&A at that point. It's just short. So if there's any questions we don't get to, believe me, I will save those and get an answer for you. So not to worry. And then we'll do a final summary of learnings and close of the day. Right, John?
Perfect. Hello, everybody. My name is John Chernesky. I'm the manager of the PLEX program at the Praxis Spinal Cord Institute. So PLEX is an acronym that we use for persons with lived experience. And really my role is about amplifying the voices of persons with lived experience of spinal cord injury, so that we can integrate your knowledge and expertise into everything that we do, whether that's research, trying to improve the way that clinical healthcare is delivered, or bringing new innovations to market. We feel that the voices of persons with lived experience of spinal cord injury is absolutely vital in an integrated knowledge translation model where we're all working together to solve these problems. One of the areas that I'm really excited about is neuromodulation. I think that there's a lot of potential for bringing benefit to individuals with spinal cord injury. And so when Terry asked me if I would help her out with this a little bit, I was absolutely excited to. And so I hope that the knowledge we can share with you today is beneficial and that you learn a few things about neuromodulation in general. And so maybe with that, we'll get started. Let me just share my screen here and I'll do a quick check. Tara, make sure that's working.
Yep, you're good.
Awesome. All right, so what is neuromodulation? Well, I thought maybe we'd start off with a brief history of neuromodulation to get you all up to speed so you can understand what we've done as human beings to get to the point where we're at now. And so let's get started. Here's what we're going to cover today. I'm going to try to keep this fairly quick because there's much smarter speakers coming up after me and I want to save time for them. But we'll describe what is neuromodulation. It's a big, complicated word, and I want to make sure that we're all on the same page about what it actually means. Next, I'm going to talk about some of the early origins, and I got to say they're a bit fishy. Then we're going to talk about some plant-based neuromodulators, see what role big pharma has to play in neuromodulation. Then we'll move forward to the age of electricity, and then we'll really focus in on neuromodulation in spinal cord injury and finish off with where we're currently at. So hold on, there we go. What is neuromodulation? Here's some various definitions about what neuromodulation is, and it's defined as the alteration or modulation of nerve activity by delivering electrical or pharmaceutical agents directly to the target area. And it works by either actively stimulating the nerves to produce a biological response or by applying targeted stimulation or pharmaceutical agents, which is all kind of complicated, but I'm sure by the end of today, you'll have a much deeper understanding. And to define a neurostimulation device, they involve the application of electrodes to the brain or the spinal cord or peripheral nerves. So really, we're talking about how we as humans can modulate the way that our nervous system works. And we do this quite a bit, and we've been doing it for quite a long time. But what does it look like? Well, we may think about neuromodulation in terms of electrical stimulation. maybe through TENS or FES, things like an FES bike, or something you can use to manage that low back pain that a lot of us deal with. Or you could use pharmaceutical agents to reduce pain or to cause an effect that you may find beneficial. To be honest, even drinking a cup of coffee is neuromodulation. The caffeine in the coffee is a stimulant, and it helps to keep us awake, and can elevate the flow of neural paths in our bodies. But where we often think about neuromodulation when it comes to spinal cord injury is often in electrical neuromodulation, whether that's in brain implants or an epidural or even transcutaneous stimulation of the spinal cord. But we'll get into that a little bit deeper later. So let's go back in history. So the earliest uses of neuromodulation date back to ancient Egypt, almost 5,000 years ago. There are murals and papyrus depictions of people actually using the Nile catfish to produce electric shocks. And they found that electrical shock coming from these fish could reduce pain. Even some Roman scholars noted that Egyptians were using electric eels to treat joint pain, migraines, depression, and things as complex as epilepsy. So it's not like this stuff has just been happening recently. We've been playing with our nervous systems for a very long time. Another one of the oldest depictions of neuromodulation comes out of China, and Emperor Shengung wrote a pharmacopoeia, which is basically a book about what plants, herbs, and other things could be used medicinally. And this is considered one of the earliest pharmacopoeias. And in that, he described the use of cannabis for the treatment of pain, inflammation, depression, and lack of appetite, which I think still holds true today. I know a lot of folks that are using cannabis medicinally, and those are areas that have been described as being, very beneficial from the use of cannabis. Moving forward, even into ancient Roman days, only just over 2,000 years ago, they also thought that fish were a neat way to modulate the nervous system. And they used the torpedo fish, which Terry mentioned to me doesn't look much like a torpedo, but that's what it's called. And they use that for the treatment of pain from things like gout and headaches. Imagine putting that fish on your head as a bit of a hat to manage your headaches. I think we've come a long ways since then, but as you can see, we've been doing this for a very long time. So what have we been using throughout history? Well, we do use a lot of plant-based neuromodulators. We talked earlier a bit about coffee, but in indigenous and traditional medicines and ceremonials, we've been using plants to modulate our nervous systems for a very, very long time. Examples of this are things like tobacco. Tobacco contains nicotine, which is a stimulant, and a lot of folks use it all the time. I don't know if it has much in the way of health benefits, but humans tend to like it. We also use things from the cacao plant. Now, cacao can create chocolate, which I think a lot of us find pleasurable, but it also produces things like cocaine, both stimulants that agitate the nervous system and can cause benefit or potentially, health detriments. Another one that we use very regularly comes from the poppy plant. Poppy plants create opium, which is a sedative or an analgesic, something that helps to mitigate pain. And when it's refined, it creates things like, why am I losing it? Heroin? Terry, help me out here. Morphine, sorry. Morphine, which is a very, very useful drug in our hospitals and clinical settings for managing pain, and it's been a lifesaver for many, many people. So that bringing things from historical medicine and pleasure in the plant world to everyday use in clinical practice. Again, getting back to coffee, again, a stimulant that helps to wake us up and keep us alert. Even things like grape and other fruits that we use to create alcohol. Now, alcohol is a depressant, can also have sedative effects. But again, these are all things that modulate our nervous system to a certain degree. And then we also use things like mushrooms. These have been used by humans for for centuries. And again, psilocybin is a hallucinogenic, and it can be used in ceremonials or recreational purposes. So again, as I said, these plant-based neuromodulators, we use them sometimes for recreational purpose, sometimes for celebratory purposes, or sometimes for medicinal purposes. And the last one I wanted to mention is sugar, again, coming from sugarcane and a variety of other sources. And again, sugar is also a stimulant. So this is just to demonstrate that neuromodulation is not some alien thing that is only happening in labs and clinical research settings. We interact with neuromodulators every day. So I just wanted to ground this discussion in something that's very familiar to all of us in ways that we modulate our nervous systems. So about, I don't know, 150 years ago, we started to recognize that all of these drugs that we were using in plant-based forms could be refined, standardized, and be made more consistent and easily available if we turn them into pharmaceuticals. And so some of the pharmaceuticals that we use quite regularly that modulate our nervous system, again, pain relievers that we interact with pretty regularly, things like Tylenol and Advil, again, analgesics that reduce the sensation of pain. Another one that we may want to worry about is things like our mental health and our mental state. And so drugs like Prozac and Zoloft, these are what we call selective serotonin reuptake inhibitors, or SSRIs, and they modulate the nervous system's ability to reuptake or how much of serotonin is present in our nervous system, which can be beneficial for things like depression and other mental health challenges. Now, I wanted to talk about one specific to spinal cord injury that we may interact with each and every day as a result of our spinal cord injuries. So things like oxybutynin, Detrol, or Myrbetriq, these are all drugs that are quite commonly used for bladder management to reduce the neurodetrusor overactivity, which is that hypercontractiveness in the bladder that allows our bladders to retain more urine, and therefore we don't need to go to the bathroom quite so frequently. These are all under a classification of drugs that are called anticholinergics. Bisacodyl, again, for those that have spinal cord injuries, often emptying their bowels can be challenging. And so a bisacodyl suppository, like the magic bullet displayed here, it's both a stimulant that causes a contraction and peristalsis in the bowel, and also works as a laxative, drawing liquid moisture into the bowels to help allow the transit of fecal matter and emptying of the bowels. Antispasmodics. A lot of people with spinal cord injury, their nervous system can be a bit hyperreflexive and agitated, causing unwanted muscular contraction. And so a lot of people rely on things like baclofen or tizanidine or dantrolene to reduce that hyperactivity in their muscular contractions, also known as spasms. And so these all are classed as antispasmodics. Pregabalin is another one that I think a lot of folks use to manage neuropathic pain under the classification of a gabapentinoid. And then the last one we'll mention here is something like midodrine for people that live with chronic low blood pressure, also called hypotension. This is something that a lot of people with spinal cord injury are reliant on. It's a vasopressor, so it constricts the blood vessels and helps to elevate your blood pressure to get it back to a level that is more beneficial for day-to-day living. We all know how having low blood pressure or hypotension can make us feel dizzy and weak, nauseous. And so getting that blood pressure up to a more normative level can really help with day-to-day activities and maintaining consciousness and cognitive ability. All right, so now that we've learned a little bit about the history of neuromodulation, and we've learned about the plant-based neuromodulators that we can use, we've talked about pharmacological advantages and the way that some of these drugs have been developed to benefit us in our day-to-day life. Let's focus now on the differences in the nervous system. Now, Today, we're going to be focusing really in on the central nervous system and neuromodulation of the central nervous system, but I didn't want to ignore the peripheral nervous system. So when we talk about the central nervous system, we're generally talking about the brain and the spinal cord. That's really what controls a lot of what happens in our body. But our peripheral nervous system is the nerves that branch out from the brain and the spinal cord throughout our body, which help to control things like the functioning of our organs, the movement of our arms and legs and fingers and toes. And it really does relay information in and out from the brain and spinal cord to the body and back again. And part of that peripheral nervous system is what we call our autonomic nervous system. It kind of runs right alongside the spinal cord, but I think it's technically considered part of the peripheral nervous system. And the autonomic nervous system is that part of the nervous system that regulates these activities that our bodies do without us actually consciously thinking about them. So that's things like managing our blood pressure, our bowel and bladder function, our sexual function, temperature regulation and cardiovascular control. And so I just wanted to make sure that you guys are all familiar with these terminologies about the central nervous system, or CNS, the peripheral nervous system, or PNS, and the autonomic nervous system, and what role they play in our bodily functions. So let's move forward into stimulating that nervous system mechanically, what I call the age of electric, when we started to harness the power of electricity and explore its potential in a number of ways. And if you go way back, almost 2.5 centuries ago, Luigi Galvani, he's the one who is credited with discovering that electrical stimulation can induce muscular contractions. And this image that you see here is from one of his works, as I said, almost over 200 years ago, where he used electrical stimulation to induce contraction of the muscles in a frog. I think most of us in school at some point or another did a frog dissection, so I don't think that is too foreign to us all. Moving forward into more recent times, as we've gotten a better grasp of electricity in the human nervous system, things like transcutaneous electrical nerve stimulation, or TENS, was first developed in 1974 by an individual named Norman Shealy. He actually was really one of the groundbreakers in neuromodulation. Not only did he create the first TENS device, but he's also done some stuff we'll talk about in a little bit. And then about 10 years later in the 1980s, we realized that, if we can contract these nerves through TENS, maybe we can take that from not just being something to alleviate pain, but we can create a functional use for it. And so that's where the advent of what's called functional electrical stimulation, where TENS is used to deliver targeted, controlled stimulation of muscles in ways that are used to facilitate specific movements. So for those of us on the call that maybe have incomplete injuries and are able to stand and take some steps, sometimes lifting up your toes can be really hard. We call that dorsiflexion or plantar flexion, where you're not able to raise your foot up. They say drop foot. And a lot of folks rely on FES to trigger a muscular contraction that will help to raise their foot up while they're trying to take a step, so they're not dragging their feet, and it makes walking a little bit easier. So that's when we're talking about functional electrical stimulation. We're talking about using these TENS devices to create functional stimulation that we can use to enhance movement in everyday life. If we focus in away from the peripheral nervous system and start to talk about the central nervous system, this is where we talk about things like deep brain stimulation. Again, going back, first developed for pain in 1973, and then eventually managed to get approved by the FDA for treatment in Parkinson's in 1997. I will admit I don't know a lot about deep brain stimulation, but we've got some smarter speakers tomorrow that can get you up to speed on what's going on in DBS, in spinal cord injury. Brain-machine interfaces were also developed quite a long time ago. The first one in 1924, the first development of the EEG, or electroencephalogram, which was used to monitor brain activity. It wasn't until 1998 that we had our first inhuman implant of a brain-machine interface that was used to control robotic arms and computers and interact with the world around it. And in the 2010s, DARPA, the Defense Advanced Research Program in the United States, really did a lot of investing into brain-machine interfaces, seeing the potential. And I think You may have heard of companies like Neuralink or BlackRock Neurosystems who have really been at the forefront of development of BMIs, but we'll talk a bit about that later on tomorrow in more detail. And now some of the areas where I think a lot of you have heard about is when we talk about spinal cord stimulation. So there's really two main modalities for spinal cord stimulation. We think about epidural or spinal cord stimulation that is implanted and placed under the vertebrae, right, resting up against the spinal cord on the outside on what's called the dura mater. Now, this was first done in humans in 1967, again by our friend Norman Shealy. But the first design was actually even more invasive. They went underneath the dura mater. If you look at that image of the spinal cord, you'll see at the top there what's called the subarachnoid space. And so he was inserting electrodes underneath the dura mater directly onto the cord, which had some negative consequences. It's less than ideal. And a few years later, again, these epidural models were developed, which are a lot more stable and are less likely to cause leaking of cerebral spinal fluid or infections to the central nervous system. But when it came to spinal cord injury, we didn't actually have our first in-human testing of epidural spinal cord stimulation until 2010. That's only 15 years ago that we've been moving this technology into spinal cord injury for recovery of function, so still very new. Transcutaneous spinal cord stimulation, on the other hand, is much less invasive. It's often considered non-invasive because it delivers stimulation of the spinal cord across the skin. So it's outside your body, much like FES or TENS devices are, where there's no invasive implantation of a device. It just lives on the outside of the skin. This was first in human done in 2015, so less than 10 years ago. And in only 9 short years, the FDA has now approved the first specialized device for delivering transcutaneous spinal cord stimulation in clinical settings. And that was approved by a company called Onward. And we'll hear a lot more about the work that they've been doing tomorrow as well. And so I just wanted to give you a quick overview of neuromodulation in general. And I wanted to map out, this by in no way is a fulsome description of all the key players involved, but I thought it was important for you to understand how this all started and where we got to. Now, I know this is quite a complex slide, so forgive me, I'll try to walk you through it, tried to animate it, but I didn't have enough time to get it done. It all starts down at UCLA, the University of California, Los Angeles, where a really pioneering individual named Reggie Edgerton, I think of him as the godfather of spinal cord stimulation. And in the early 2000s, they did a lot of work in animal models. And in 2010, over here is Susie Harkema, who was a student in his lab and went on to become a very accomplished researcher in her own right at the University of Kentucky in Louisville. She did the first in human epidural spinal cord stimulation trial in 2010. And that was really a watershed moment. The findings of that were quite astonishing, and you'll learn a lot more about that as well. A couple other students that came out of Reggie's lab were folks like Gregor Curtin, who's now at EPFL in Lausanne, Yikai Lau, who's still, I think, associated with UCLA, and Parag Gad. Again, 4 of the big pioneers in this field, and they've all had their own impact on spinal cord stimulation. So Reggie, after seeing the effects of spinal cord stimulation, started a company called Neuro Recovery Technologies in 2011. Now that eventually merged with one of Gregor Curtin companies, G Therapeutics, to form GTX Medical, which now is known as Onward. So you can see how it's all sort of interconnected. One of the biggest, I think, validations of spinal cord stimulation actually happened at the Mayo Clinic in Minnesota in 2017, where, led by Dr. Kendall Lee, they replicated the research that came out of the Harkema lab. Now, if you're not familiar with research replication, it really is the gold standard in showing that something is, in fact, can be believed to be true. So what happens in a replication study is an individual or a lab completely independent of the first lab that conducted this research goes ahead and replicates that exact same research, doing the exact same thing, using the exact same protocol, that happened elsewhere. And by independently verifying the results from a study, it can be said that there's a strong degree of evidence that that's true. Now, the challenging thing about replication studies is they're very, very rare. Unfortunately, research isn't designed to replicate the works of others. Oftentimes they want to see novel research. And so I really do commend Kendall and his lab and everybody involved in replicating that work so that we as a community could validate and be confident that the findings at the Harkema lab were in fact true. Also in Minnesota, Dr. David Darrow saw what was going on. He heard about the research that came out of the Harkema lab, and as a surgeon, he always said to me that he felt that he wanted to be able to do more for his patients, and so he got into research as well and started the ESTAN trial to really expand the breadth of knowledge about the impact of spinal cord stimulation. A person whose name I didn't put on here is Dr. Andrei Krassioukov, who you're going to hear about later. And for those of you based in British Columbia, I think you'll be very familiar with him, Dr. K. And he's been integrated and involved in a lot of this work. I think his fingerprints are on pretty much everything you see here, really being the world's leading expert in autonomic dysfunction after spinal cord injury and making sure that we were capturing the autonomic effects of all this work. And lastly, I just want to also mention Yikai Lau and Parag. They've also established their own companies, Inuvo and SpineX, that are both working to develop transcutaneous spinal cord stimulation modalities. But again, you'll hear more about that from people much more qualified than me tomorrow. All right, so before we move on to our next step, I don't want to run too long, and over time, I think I probably am already. Where are we now? So things like deep brain stimulation, brain-machine interfaces, even transmagnetic stimulation, which I didn't get a chance to talk about, but we'll talk about later tomorrow as well, and epidural spinal cord stimulation. They're still in the research phase. There's ongoing research into the safety and efficacy, and multiple groups are developing specialized devices for the restoration of function in spinal cord injury, because a lot of times they don't exist or they're not yet refined to the point where they're ready to push forward to mass market. Transcutaneous spinal cord stimulation is slightly ahead of these other modalities. Again, there's still ongoing research into the safety of efficacy in spinal cord injury, but also that's showing promise in other health conditions like cerebral palsy and muscular multiple sclerosis. There's continuing work in the development of these specialized devices. And as I mentioned, we have one device that has been approved for use, but only in a clinical setting and only in the United States. And as I said, we've got some folks from Onward that'll tell us a bit more about what they're up to tomorrow. So with that, I'm going to wrap up, and I think we're going to bring in some folks who have a lot more knowledge about the effects than I do.
Well done, John. That was only a minute over. I'm very impressed.
So now what we're going to do, we're going to have a bit of a panel discussion with individuals living with spinal cord injury who've experienced neuromodulation. Because I think there's no better source to hear about what spinal cord injury means to people with spinal cord injury than individuals with spinal cord injury who've experienced neuromodulation. So I'm going to go ahead and just start introducing folks. Right, so first, I'd like to introduce Mathew Szymanowski. Mathew is a C6 AIS-B or Asia-B tetraplegic. He lives in Toronto and is studying biomedical engineering at the University of Toronto. We're really hopeful to pull him in even deeper into the praxis universe with that lived experience and biomedical expertise. He was injured about 6 years ago, and shortly thereafter, about 5 years ago, he traveled to Thailand where he paid to have an epidural stimulator implanted. And then about 2 years ago, he actually had his stimulator reprogrammed at a clinic in Calgary. Next, I'd like to introduce Bryan Anderson. So Bryan is a C4 AIS-A tetraplegic, and he lives up in Golden, BC. He was injured in Nicaragua in 2023, and he recently participated in a research study on transcutaneous spinal cord stimulation here in Vancouver at I-Cord. We've also got Alex Hidgen. Alex is a C6 AIS-B tetraplegic, injured about 6 years ago. Like Mathew, he also traveled to Thailand to have an epidural stimulator implanted, and that was about 4 years ago. And after returning home, told me that he found that the stimulator wasn't providing the kind of benefits that he was hoping for. And so he also visited that same clinic in Calgary to have a stimulator reprogrammed, which he feels greatly improved the effects of the stimulator. We've also got Peter Grahn, and I believe, Peter, you're a C5 tetraplegic. Correct me if I'm wrong.
Yeah, sorry about that. I had to mute. C5 injury, incomplete. So sensory partially intact, no motor.
So AISB then.
Yeah.
Peter is a very accomplished researcher at the Mayo Clinic in Rochester, Minnesota. I think he may have been involved somewhat in the study that we mentioned earlier with Kendall Lee. And he has been involved in research on the effects of spinal cord stimulation for around 10 years now, I think. He doesn't himself have personal experience of neuromodulation, but his deep understanding of living with SCI and neuromodulation brings a breadth of knowledge to our discussion today. And he will also be presenting tomorrow during our rapid fire sessions on the current state of epidural spinal cord stimulation. We've also got Mooj Tabasoli. Now, Mooj is a C4 tetraplegic who's lived with SCI for the last 13 years, and he's participated in quite a few transcutaneous spinal cord stimulation clinical trials at ICORD that were focused on recovery of autonomic functions. And lastly, we've got Alana Jones, and she had her spinal cord injury about 10 years ago. She's also a C4 AISB tetraplegic, and she also participated in clinical trial at ICORD looking at the effects of transcutaneous spinal cord stimulation. All right. I think that's everybody. Did I get them all? Awesome. All right. So maybe we'll start off, now that we've done some quick introductions, maybe I'll just ask you guys a little bit to, put some color into what I just explained. You've all experienced neuromodulation. Does anybody want to tell us, what it was like, where you went, and how it all happened?
I can jump off the bat and say that anyone that came to Mayo said it was an amazing experience because we're a great team. No, I'm kidding. I can, as far as what I've observed from experiences, it's been enjoyable that people have tolerated the stimulation fine. So, yeah, I'm interested to hear what everyone else has to say about their own personal experience.
Well, for me, when I went around COVID time, and we quarantined for, I think it was about a week, and then from there I was in Bangkok for probably about 2 months. I actually extended my trip because I was seeing such great movements and stuff from the stimulator. But it was about maybe a day after, as soon as I turned the stimulator on, movement was pretty much, something was happening. So yeah.
I'll jump in as well. Thanks so much, John, for the background on transcutaneous stimulation so that everyone kind of knows a little bit about it and what it is. I think that's important. And so I think for me personally, I had quite a bit of autonomic recovery. That's what we assessed before and after the trials that I did. And so I think that in terms of autonomic function, there was quite a few things that I saw a lot of benefits with, specifically blood pressure. In the morning when I get into my chair, usually I have to tilt back a little bit, maybe cross my legs, just trying to get my blood pressure, to get used to my new position. And during the trial, when I was getting the electric stimulation, I started noticing that when I got into my chair in the morning, I didn't have to tilt back. I didn't have to take my time to wait for my blood pressure to regulate. It was just, it adjusted to my position, which I think a lot of people here can appreciate. And I think also temperature is one of the big ones. You would never, ever see me in a t-shirt before I started doing the transcutaneous stimulation after my injury. And I think that was a significant thing, especially living in Canada, where it can get quite cold sometimes. And even during the summer, you would see me wearing a really thick hoodie And so I think that's some of the benefits that I really noticed.
Nice. Yeah, I see quite a few toques on the screens here, so I think temperature regulation is a big one for a lot of us.
Yeah.
All right. Well, maybe, we know a little bit about you guys. We know a little bit about how you, experienced in neuromodulation or got involved. But I guess maybe let's just dial the time frame back a little bit. And I'd like to know a little bit about how you actually heard about neuromodulation. Like, did you talk to other people about it? Did you learn from peers with spinal cord injury, or did you talk to medical professionals, or maybe a family or a friend mentioned it to you? Before you decided to jump in, did you do your homework? Were you reading articles or publications or watching videos or asking experts in the field? Yeah, what brought you to it? How did you learn a little bit about it?
Yeah, I can speak on that. So I, similar to Alex, went to Thailand to get my stimulator done, and it was kind of I got it done right when I got injured, so I was just kind of trying anything at the time to see if like I could get as much improvement as I could, and that was the thing that was kind of popular or like talked about time. There was like a pretty notable or in the media, like a bus crash that happened with one of the I don't know if you guys would remember, but like it was just a bus crash of a team in Calgary, and one of the members had a spinal cord injury, and they went to Thailand to get this stimulator done. People might know him. His name is like Ryan Chernesky. So I went to the same clinic as him. Yeah, somebody said in chat, Ryan. So, and I had a really good experience. Yeah, that's kind of how I found out.
Yeah, no, me as well. Same as Matthew. I also reached out to Ryan, and also another guy in Vancouver. His name is Isaac. I met him here, and then saw him and saw the movements he was getting, and then reached out to Ryan. He basically said, "Yeah, it was great," and then I was on a plane going there.
Yeah. Interesting. Anybody else want to share how they learned about it? I haven't heard much from you yet, Alana.
Yeah, I actually, Mooj told me about it. He reached out to me and said he had really good results with the stim and that I should try it. And I also had pretty good results. I have like stopped taking as much midodrine for blood pressure. So that's great. And just like overall my AD has gone down and stuff. So I feel like I had a really good positive experience with it. And I feel like I didn't need to do any research because I trust Mooj. Like somebody who has a spinal cord injury knows that we just want to do whatever we can do, right? So like sometimes I feel that's the best way. Yeah, I don't.
Awesome. And what about you, Brian? You're not living in the Lower Mainland and around Vancouver. You're quite a ways out of town. So how did you hear about it?
Well, I got to spend my fair share of time in Vancouver. After breaking my neck, I somehow made it back to Canada with a lot of help. Yeah, I struggle with my blood pressure is a roller coaster. So goes daily over 200, and then if I try to I get low blood pressure and pass out every few days kind of thing. So I had heard about a doctor and through a friend of his, a doctor reached out from Calgary that had the implant done, and Richie Gill. I don't know if any of you know him, but he went to Thailand as well, and he was battling blood pressure and had incredible results. And I think that was my initial, what I had first heard about it and stuff. And then it was actually Ryan Clarkson, I think, doing the information talk actually at GF Strong when one of the lunchroom talks was about, clinical trials and research and stuff, and kind of mentioned this is kind of something super exciting, and then I started, Googling it with my spare time, and so I did a bit of research for sure before I dove in. I wasn't ready, I don't think, to go for an implant. The invasive, I wasn't just ready for it. I had a bunch of surgeries, and I just wasn't on my agenda to begin with. But I mean, certainly after I was the non-invasive one, worked well for my blood pressure. So again, like everybody here is saying, the autonomic benefits worked really well. Like I can't stand up in the standing frame very often, and I really struggle with it. I got binders, compression socks on. I can't remember which week, but eventually, like probably after a month, I was finding myself going downstairs after stimulation, no binder, no socks, no nothing, and getting stood for 30 minutes, no problem. I could go up and down. I can't lie down without my blood pressure going really high. And I was able to lie flat and stretch on benches. And those benefits lasted for quite a while. I want to say a couple months post stimulation. It does start to go down like within days, I found. But, we went back the following week and it would boost it again. And yeah, it took a while for the effects to kind of wear off. Now I'm back to where I was, where I'm really struggling blood pressure wise. And I think, as Mooch was saying, temperature regulation, that was, again, I saw the exact same benefits. I wasn't scared when a cloud covered the sun on a cold day, and I wasn't scared on a hot day as much. And yeah, so nothing positive. I got all positive things to say. My main concern starting the trial was more impacting my family, because it's the distance and everything. And I just got to say, the researchers, obviously you guys have any experience at the I-Court facilities with the researchers and everybody there. It's fantastic. I learned a lot about my injury. Yeah.
Awesome.
Anyways, I'll let somebody else talk for a bit.
Awesome. Yeah, I feel like you've stolen a lot of my questions, Brian, because you already answered.
Sorry, man.
That's okay. That's
Sorry,
all
Don.
One thing I want to ask is, there's a lot of people on the call that have spinal cord injuries that may be curious as well. Now, you guys all, put yourselves forward to try something that you didn't necessarily know if it was going to work, if it was going to be good or bad. So I'm wondering, what were you thinking? What made you choose to try it? Were you nervous or afraid? Was there something, a health related concern that was really like, you were like, I can't live like this, I need to try this? What were you trying to get out of this? What were your expectations? What were your big concerns around your health that you thought neuromodulation might help with?
Well, for me, I first found out about neuromodulation through Dr. Hakima's study. When it came out, I kind of followed it, and when it was finally available locally to me at I-Court, then I signed up right away. And one of the things that, there were two main concerns that I had. The first concern was that everyone's spinal cord injury is different. Like the nervous system is so complex, and so I've met and I've spoken to a lot of people that have some really, really bad nerve pain, and I'm fortunate not to have that level of nerve pain. And so that was one of the things that I was worried about. I was like, okay, if I do this and I get some sort of recovery, what if it's painful recovery? And so that was one of the big things that I was concerned about when I decided to join. It's all like for me that time, it was unknown. Like nobody said you would or would not get nerve pain. Fortunately, I didn't. But that was definitely one of my concerns. And then another of my concerns were kind of the assessments before and after the stimulation. Some of them aren't as comfortable. It depending on which trial you do, but really at the end of the day, I'm so glad that they had those assessments, because we were able to properly track the progress and the effects of the stimulation. And so at the end of the day, I think it was all worth it for me.
Awesome. Anybody else want to talk about that decision-making process?
Yeah, I wasn't worried at all when I went. I was, when you make a decision to go to Thailand, you're kind of all in. So I was just pretty, even like the day after, it was pretty, the surgery is only like 4 hours, and then, you're back to it pretty much the next day. And yeah, it's pretty good for me. Yeah.
Awesome.
Yeah, I have a question for Mathew. Mathew, you said that you went and you had an epidural stimulator implanted, and then you went a second time. It got reprogrammed, and you saw more benefits afterwards. Is that correct?
Well, I didn't go back to Thailand. I went to Calgary to get it.
Okay.
Yeah, I went to Calgary as well, same as Mathew, to Synaptic. I think it was a year and a half ago now. Yeah.
And so what positive changes did you see after the reprogramming?
So when I first got the epidural stimulator, it's like a 2-month process of them trying to figure out what electrodes map to what muscles, and they set certain programs on there. So over time, those electrodes get demapped almost, the mapping gets off. So they recommend going back to reprogram it and make it more effective to hit those muscles that you want and have the same effect or even better effect. So some of the functions that I used would be for leg extension or for core contraction, or I use a program for helping decrease spasms. And for me, the one that improved the most would be program that helped me with decreasing spasms. I guess, yeah. Do you have any other questions surrounding that? I feel like that was a lot of information.
Yeah, so what about autonomic functions? Any bowel, bladder, sexual functions that improved after the reprogramming, or even when you had the device put in the first time?
Yeah, so I didn't see much of a difference in terms of autonomic functions. Maybe a little bit for bowel with the core programs. If I set them to a high intensity, my core muscles would contract a little. So when I would do my bowel routine, I would try the core program, see if the contraction would help. But eventually I stopped using that. I just found the suppositories and just without it worked the same way.
I saw a big difference. I'd be on the toilet for sometimes 2 hours, and then with the stimulator, I can get it down to 20 minutes to half an hour using the stimulator.
Pretty impressive.
Yeah, it's pretty crazy.
I wonder, we've got Peter on the call. Andrei's got his hand up. Andrei, I'm going to call on you in 1 second, but I'm going to ask Peter first. Peter, you've obviously been doing this from a research perspective, so you're familiar with mapping and programming these stimulators. Can you talk to us a little bit about epidural stimulation and the process of programming and reprogramming, mapping the stimulation parameters?
Yeah, can you hear me okay?
Perfect.
Yeah, so I can't speak to what is done in other places or in Thailand when they call it programming, reprogramming. What we do at Mayo is so we put electrodes on the legs of the muscles that we're essentially trying to stimulate over the skin, and those record muscle activity, electromyography. And then when we stimulate, each pulse of stimulation, we look at the EMG and see which muscles of each leg are active and how can we balance or how can we target a certain area of one, whatever the function is we're trying to restore. And then we move from there, different frequencies or rate that the pulses are firing, and then their intensity or their amplitude, you can adjust that as well. So those are kind of the three main things that we're adjusting: is the location or the target of stimulation, the frequency, and then the pulse amplitude.
So
And-
this, sorry,
No,
the
go ahead.
signals
Go
that,
ahead.
yeah, so the signals that you're getting from the electrodes on the legs or on the muscles, are they coming from the stimulator or from intentional brain activity?
So usually, if it's set up right and like there's not any noise coming through, you can pick up the artifact from the actual stimulation pulse that's delivered, and then a few, like 10 to 20 milliseconds later, you capture the muscle activation as it because it travels down the peripheral nerve and then activates the muscle, and you can see that. But it's also it's a little bit tricky because if your pulse rate is fast enough, it'll interrupt that recording before you even get to see which muscle's activated. So it's kind of a
It's a work in progress.
it's a give and take. You want to pick a frequency that you can record reliable or usable data, but then in some cases that frequency may not restore the function that you're trying to achieve. So
I think there's a bit of trial and error with the programming, and sometimes you get it perfect the first time, and then sometimes things change and you have to modify that programming. I don't think it's a one and done situation. But I see we've got Dr. K here, and I see you've been patiently waiting to share his thoughts. So maybe I'll ask Andrei, what did you want to share there?
hopefully he doesn't correct everything I said.
No, no, first of all, I'm truly enjoying to see familiar faces of patients and participants of my clinical trials and people who did a lot of interesting science outside of Canada. I just would like to, I have one question to all participants and one clarification. With the present setup of epidural electrodes, which has 16 leads, we have almost 22 million variations of setting different programs. And that's why the programming or mapping, what we call mapping, is absolutely, absolutely crucial part of research which is done for motor mapping or autonomic mapping. And we do know that the same electrodes which activate muscles of lower extremity sometimes will not activate sympathetic neurons for bowel, bladder, sex, or blood pressure. That's why mapping has to be done in totally different ways for everybody. And again, with time after implantation, we do know that electrodes will change somewhat position. It could slightly move. And that's why this is what probably some individuals experience, that additional mapping can go to the Thailand or go to Calgary will be helpful to improve outcomes. I have questions to all individuals who went abroad for implantation. What was the primary moving factor to choose Thailand? And how you guys and your family deal with financial cost that was involved?
Alex and Mathew, if you didn't quite catch that, he was wondering what was the motivation to go there and how did you manage the burden of that cost? And I think some people also on the call are interested to know how much it did cost.
Yeah, so when I went, it was 98,000 US, and the exchange rate was about 120,000. And then plus quarantine was about another, I think, $5,000. And then I extended the trip another week, which was another $5,000. Yeah, it's not cheap. Yeah,
And-
I saved up a lot, and then I had some help from my parents as well.
Yeah, for me, I had a really supportive community, and they fundraised a lot of money for me. It was pretty much the same cost. I don't know exactly because that was handled by my parents, and it just basically my community was able to raise that much money for me to go. I did look for local options at the time. So I went in 2020, and that's when COVID just started. And I had an idea that like getting it done as early into my injury might give more benefits. But I did look at local trials. So I did look at a trial in Calgary. I forget his last name, but his first name was Eric. But that was like delayed because of COVID. So yeah, that's the reason why I chose that clinic. But another reason is because they had a lot of experience. So I knew that Ryan Chernesky went there. Granted, it like Peter said, like the process isn't as like scientific based. So like they don't measure EMG response and filter out the like noise and stuff. It's more like trial and error, which yeah, like it's obviously it's different. And yeah, they measure it through like putting you through exercises and seeing like what muscles can activate.
Do you guys think it would be fair to say that you took a bigger risk by going to Thailand than maybe if you had been involved in a clinical trial? I know you both kind of mentioned the urgency that you felt, and I think maybe it was faster and easier to just go and pay for it than it would have been to wait to get into a clinical trial. But with that, there's added risks. How did you guys weigh that benefit of paying for it and those added risks compared to what it might have been like if you were in a clinical trial?
Yeah, for me, unlike Matthew, I waited about 3 years after my injury, and I found there's nothing else that's going to be better than this. So that was it. I was going. And then, but at the time I was going to Thailand, there was also an opportunity to go to Mexico and get it done. But the thing about Mexico is they didn't have as much experience as Thailand. So the therapists there, basically they're winging it, and they turn on the unit and see what works. And then if that doesn't work, we're trying something else. And then we just consistently are trying multiple variations of different programs, and then combining programs as well. Yeah, pretty much.
Does anybody know if there's any option to go overseas and receive the non-invasive version of the neuromodulation?
That there's no like clinic that I can tell you about off the top of my head that can do it. The non-invasive, I know that Seattle, the University of Washington, will be one of the first sites to use the newly approved Onward device as part of their regular clinical practice. So I think that at some point in the near future, transcutaneous stimulation may become more widely available. I think Onward is looking to expand into other jurisdictions, and some of the other companies are looking to get regulatory approvals for their devices as well. But maybe we'll discuss that in a little bit more detail later today and tomorrow. I do want to broaden out the conversation. We've got a lot of questions to get through, and I only have so many time. But one of the things I wanted to ask, and I think there's a question that came through as well in the chat, is what does it feel like? I think a lot of people, can you feel it? And we all have different types of sensation and ability to sense and feel. But I'm wondering, when you get that stimulation, does it hurt? Is it comfortable? Does it feel good? Does it feel bad? What does it feel like when the stimulators are turned on? Alana,
it feels really cool. It's almost like you're turning on your body again. It's really weird. Yeah, for me, yeah.
Yeah, with the non-invasive stimulator, I found that it felt like, so I have a phantom limb body, and when I was using the stimulator, I felt like I was inside of my body. Like I could actually feel my body instead of my ghost body. And like the sensation of where the stim is, I would say, like, to me, maybe it kind of felt like a vibration. Like it wasn't anything really scary. It just felt like regular stim does, like a regular, like one that you would use at physio. Like I didn't really notice anything too painful about it, but I'm not sure about anybody else.
What about you, Brian?
Yeah, no, like everybody said, it's I didn't have any discomfort with it at all. There were some strange feelings, here and there, like getting the settings and changing and that, but yeah, no, overall, yeah, I didn't have any pain with it, it was yeah, very, very comfortable. I'm always slouched all the time, obviously, at our levels and stuff like that. For me, when I got the SpineX machine would get up to, it took me a while to get to the 70% or whatever. But at about that mark, between there and 100%, my body just, like my core engages, and I was, able to sit up straight, and it did that. Even that feels just amazing. And I even being diagnosed with AGA, I did get a bit of leg movement with the stimulation while it was on, which is kind of exciting. But anyways, I'll let somebody else talk there. I know we're short on time.
Yeah, so for me, I think so when I first did the simulation was during mapping, and I was lying down, and I was hooked up to everything. It was a little bit like overstimulating when I was doing the mapping. And so when I finally started doing the trial regularly, and I was in my chair, comfortable, and I can pay attention. Am I AD? Is my blood pressure low? Like how I feel? Like I can pay attention to my body. And I had actually some time of about maybe a few days of using it, and I know, okay, I'm not just gonna I'm not just gonna randomly, like, my blood pressure is not gonna shoot up. Like for me, and just kind of like I'm more comfortable, like trusting it. After that, that's when I think I started seeing most of the benefits, because then I had the freedom to let's see, maybe I can try moving my legs, maybe I can try coughing. Again, the trial that I joined focused on autonomic recovery, so we weren't even looking at those benefits unless you do like a case study or something. But I did try moving, I did try coughing, I did try, just experimenting and just seeing what I could do with the sensation that's going on right now in the stimulation.
Awesome. Well, now that we're sort of pivoting into the recovery of movement, we've all talked a little bit about autonomics. Do you guys want to tell us? We've got some questions coming in the chat about movements, upper limb, lower limb. I think, we've had some talk about restoration of core function and balance. What do you guys feel in terms of movement recovery, not necessarily the autonomics, but the movement? What's been the biggest benefits for you, or has it benefited you at all?
Yeah, can I add to that question, John?
Sure.
I know there was a comment earlier from someone about like they noticed movement occurring right away when they turned it on, and I imagine some of you, or probably most of you, have had FES, like skin surface stim, at some point. And I'm just curious, when you say like right when it turned on, you saw movement. How does that compare to FES, your experience? And because FES, like, you can maybe feel it or you can see it, but you can't control it. And when this is turned on, even right away, did you feel like you could control it in some way, or is that like a learned thing over time? Or maybe that's not what you experienced.
So before they jump in, I'm just going to say that from my experience, I've also participated in clinical trials with spinal cord stimulation, and to the best of my knowledge, the stimulation is turned up to what they call a submotor threshold, so that, because if you stimulate the spinal cord, you turn it up high enough, it's going to cause muscles to contract, just like an FES, but they stimulate below that level so that the muscles won't involuntarily contract. You actually have to consciously try to contract them. And Andrei's got his hand up again, so I think he wants to correct us.
I think there's multiple strategies, but
Yeah, Peter, it's a very good question. That's what is it exactly? Is it stimulation of the muscle itself causing contraction, or it's a really we're activating some intrinsic pathways in the spinal cord and we voluntarily actually contracting? I can tell you from our experience of right now, 20 patients completed various clinical trials, people who are present in our audience, and I will show you actually Muj recovery. He was able voluntarily control his lower extremity. It was that what we believe, spinal cord stimulation amplified coming from the brain impulses that were able finally to reach the motor neurons. And Muj, for example, clearly was able to contract his lower extremity on command with spinal cord stimulation. This is what is exciting about this. And again, in the Muj case, we did not expect motor recovery. We did not focus on motor recovery. It was really accidental finding in his case and in other patients who were involved in the trials.
Yes, and for me, definitely, when the stimulation is off, I am not able to contract voluntarily at all. And this is also partly why, Peter, when you were saying earlier about when you do your research, you put the electrodes on the legs, so the EMG results. And so when we did the EMG results on me, we just it wasn't part of the study. We just checked it out, and basically without intention, so without me trying to contract my leg muscles, there was no response on the EMG. There was no jump in electrical activity in my legs when I didn't intend to move it, even with the stimulation on. So if the stimulation is on and you're reading my leg muscles and I do nothing, there's no response in my leg muscles in the EMG. And as soon as I put the intention to try and activate the leg, so it basically means that it's not causing the movement of my legs is not coming from the stimulation, it's coming from my direct intention.
Yeah. So maybe while we've got Andrei and Peter, who are two experts in this field, I think just want to clarify, I think a lot of people hear this term that somebody severed their spinal cord. It's extremely rare for anybody to sever their spinal cord, i.e. to cut right through it. For the most part, most injuries are a bruise of the cord, and some of that tissue dies and there's a scar. But for most people with spinal cord injury, there is some residual tissue that's still connected from the brain down through the cord to the lower body. And I think there's a belief, and Peter and Andrei, correct me if I'm wrong, that this stimulation, whether it's epidural or transcutaneous, is amplifying the dormant signals that are coming through that part of the body and now allowing them to pass through areas where they were not previously able to. I wonder, Peter or Andrei, do you want to argue with me about that, or does that sound about right?
Peter, go ahead.
I think from like a conceptual or evidence-based theory, I think that's probably in some way the case, but I don't think we really know. I mean, you can't tell me that, like, if somebody turns it on right away and they're able to move in the ways that people are describing here, that's not stimulation-induced changes in the circuitry across the injury. Like, there has to be some connections there. Yes, you're right. Almost no injuries are, I should go back. Almost no injuries are complete severed cord. Like, they call it a complete injury. That's from a clinical diagnosis. The person sees them, they're complete, they can't move, go on about their life. But most people probably have tissue across the injury that's intact.
Peter, you're absolutely correct. And John, you're absolutely correct. That's why clinically we're dividing patients for complete injuries, and it's a AIS-A, motor complete and sensory complete. AIS-B is a motor complete, sensory incomplete, and AIS-C and D, motor sensory incomplete. But it is a clinical, Peter, you're absolutely correct. It's a clinical definition. In reality, morphologically, majority, 99% of people with spinal cord injury still have partial preservation of ascending and descending pathways within the spinal cord, unless it was a knife or bullet went through the spinal cord. And that's why right now you probably could soon see more and more term discomplete injury, discomplete, which describing preservation of anatomical connections within the spinal cord. But this small amount of spinal cord tissue, sometimes silent, it's not powerful enough to cause movement. And that's where we need some kind of additional trigger, additional boost. And spinal cord stimulation, epidural or transcutaneous, actually provides this boost to the silent fibers become functional. And that's what we see, for example, in the Mooch case.
Awesome. All right. Well, we've only got about 10 minutes left, so I don't want to take over the conversation too much. Maybe we'll get a couple more questions in. We did have a question come in from Marnie about muscle activation and muscle growth. Now, a bunch of you have mentioned that you stimulator turned on and you were able to reanimate muscles that were previously paralyzed. Did that happen easily? Did it take a lot of time? Did you feel like the muscle buildup took a while? Or did it feel like you were able to regain strength to a point similar to pre-injury pretty rapidly?
Yeah, I can speak on that. So for myself, the way that I would control the muscle activation is, I mean, I'm AISB, so technically I have no motor underneath my injury. But I would kind of like arch my back to make the contraction, and then I would like relax. So we would try like to simulate walking, and to simulate this, I would do kind of like an arch back, and it would like kind of make my hip flexor flex and kind of almost work like as a spasm, amplify a spasm, which would do that. And I noticed like we did that for essentially 2 months while like adding the mapping. And obviously with the mapping, the activation got better, but also the muscle tone, did improve. And then I would use like contraction, like leg extensor contraction and standing frames, which would also help with like blood pressure and muscle tone.
Awesome. Alex, you mentioned to me some impressive muscle recovery.
Yeah, for me, similar to Mathew, when I got to Thailand and they turned on my standing and walking programs, my like the standing was not perfect, but then over time, my legs are able to lock out with the stimulator on. And then also when I'm in the walker, I'm able to now isolate each leg independently without my physios or anyone holding my other leg back. It's not perfect by any means. And they do buckle sometimes, but it's better than it was. It just continues to get better over time, but it's taken a lot of time to get to this point. Yeah.
So you were able to activate them quite quickly, but building up real strength took longer.
100%. Yeah, definitely.
Awesome. I wonder, we think about all these changes that you guys have had, autonomic recoveries and motor function recoveries. What has that meant in your day-to-day life, your real life? Like, has it improved your strength, your ability to do things of everyday life, like taking care of yourself, or your mobility, your hygiene? Have you been more productive in work or school or family life? What has it meant to you in the real world?
I just want to say one thing. So I've had it happen 2 times. This is not making my life easier. Well, hopefully one day. But there's been 2 times now where I feel in my stomach, oh, I think I'm gonna have an accident. And then a couple minutes later, maybe a minute later, that's what happens. And like, it's shitty to have an accident, sorry. But at least I was able to tell that it was going to come on, and like having a little bit of warning gave me that second to go upstairs and start getting change. yeah, I don't know about anybody else.
For the, I just saw a comment for Roderick. I'm an Asia B, so motor complete, sensory incomplete. Yeah.
What about you, Brian? How's it impacted your life? I know the effects have worn off now, but when you were in the trial, when you were getting that stimulation, what did it mean? You mentioned having better posture, but did it help with moving your wheelchair around or doing activities of daily living?
Energy, yeah. Like I had way more energy than normal, and that just allowed me to do more throughout the day. You know, yeah. I never thought I had, until like I had a bit of with the autonomic functions, everything improved a little bit. Like, but yeah, the big ones for me, the blood pressure for sure, and the temperature regulation. It just allowed, like I said, allowed you to go outside, not be scared if the cloud shows up over the sun, or they are the opposite, But yeah, no, I would definitely recommend it, and I would do another trial in Vancouver.
Brian, can you tell us about your red and white faces?
Hi, Dr. K. Good to hear you. What's your question?
Can you tell us about your periods when you had extremely red face or extremely white and pale face?
Yeah. Sorry, I can't hear that.
Sorry, about your face. Sometimes your face was very pale and sometimes very flush.
Oh, yeah. It still is, but yeah, no, it was amazing. Like if my blood pressure would spike at the beginning, the machine would fix it. If my blood pressure dropped, it would fix it. Like it was, yeah, no, unbelievable how it helped with the blood pressure. And that again, the pale and the red face, and better sleeps, more energy through the day to do more, but then better sleeps at night too.
Awesome.
And sorry.
I was going to say I'm a strong believer that the improvement in cardiovascular function from spinal stimulation may prove to be very beneficial for wounds as well. I think pressure injuries and wounds are a big risk for people with spinal cord injury, and we talk about the three main risk factors being, reduced mobility, reduced sensation, and reduced circulation. Anybody who has any of those three things is at high risk, and in spinal cord injury, we have all three, so we're at extreme risk. And if we can take one of those out of the equation, obviously the mobility is great, sensation is great, but by improving that cardiovascular output, getting that circulation better, I think that could play a big part in helping to heal wounds. Mooj, I'd like to ask you as well, because obviously you mentioned a lot of changes in movement, lower limbs, but as we know, for people with injuries like yours, triceps and biceps and wrist function and hand function are so important. Did you notice any changes in any of that in your day-to-day living?
Yeah, that's a really important question, because some people ask me, like, would I consider going and having an implant done? And before I joined any transcutaneous stimulation or non-invasive stimulation trials, I would have considered it much more than now. Now I can see, so I'm sure you're kind of getting a theme here between myself, Alana, and Brian on how the transcutaneous stimulation works. But one of the main benefits is you're not set to a specific location. So the trials that I joined had specific locations. But when you are able to have access to the stimulation, you could, depending on your injury or the movement that you're looking for, the benefits you're looking for, you could put it at basically whichever location you prefer. So, for example, I did not get stimulation around my cervical area. I have a C4 Asia B injury, but if I did, there may have been a potential to have some upper body function, because that's where the nerves come out. I did not have any improved hand function during the trial because I had stimulation lower down. But I do want to mention, going back to the question you asked earlier, how it feels when like when you first regain a movement. And before, if you ask me, because like I'm 13 years post injury now, and if I imagined how it would feel to like move my leg again, I imagined it would be unnatural, unfamiliar, sort of difficult. And I did have to put effort into moving it. But once I had the connection, once the stimulation was on and I was able to move that muscle, it was a very, very familiar feeling. It did take effort. I'm not saying it didn't take effort, but it was way more familiar than I expected. I thought I would have forgotten and it would have felt weird, and but no, it was a very, very familiar feeling. It's almost like doing a movement with your arm in the air and then grabbing like a pulley system or a weight. Like I felt that connection where like I'm actually pulling something and I'm not just sending out signals. And I think that's how it happened with me, definitely.
Awesome. We are about to take a break, but I did want to just ask Peter one quick last question before we jump to break. And Mooj, what a tremendous response. Thank you for sharing that. But we did get asked about, our panel here is a bit biased. It's all persons with cervical spinal cord injuries, all tetraplegics. There's obviously some paraplegics on the line as well. So is there any difference in effect between tetraplegics and paraplegics, or is it similar in your findings?
So our studies have all focused on the lower legs, just the way they're designed and stuff. But we do study people with cervical injury in that scenario. So whether your arms are working or not, we're stimulating the legs and we're seeing effects across the spectrum, whether they're cervical or thoracic injury. We have not implanted anyone in the cervical region for arm function. There are studies going, there have been studies looking at that, but that's not one area that I'm intimately involved in or anything. I can imagine it would work similarly, but it's also a smaller piece of real estate to work with in the neck, and there's a lot of other vital functions surrounding that you would want to be careful with, I would say.
I'm pretty sure when I was actually in Calgary getting remapped, Dr. Ritchie was getting remapped as well, and I'm pretty sure he has 2 units. He's got one in his back, and he's got one in his neck as well. I'm pretty sure, but I'm not sure 100%.
Next time we do one of these panels, we're gonna have to invite Richie to join as well. Anyways.
Yeah.
I would like to say one more thing. Sorry, John, I know you guys are running out of time, but something that we didn't touch on is sexual function. And I think because we have Dr. Stacy Elliott and we have Dr. K talking about that today, I think we should just touch a little bit on it at least. And for me personally, I did get more frequent erections and I did get more sensation in areas. And then the last thing I want to mention is that when I have the stimulation on, my category changes to AISC when we do the INSCI test.
Awesome. All right. Well, I'm sure Dr. Stacy Elliott will talk a lot more about the recovery of sexual function later. All right. All right. Well, that was a great couple of sessions to get us started. Thankfully, Dr. K or Dr. Grahn didn't correct any of the things I said earlier in my presentation, so hopefully I got most of it right. Anyways, we are very lucky to have Dr. Rahul Sachdeva join us now. Dr. Sachdeva is an assistant professor in the Department of Physical Medicine and Rehabilitation at the University of Kentucky. He's a translational researcher focusing on both preclinical and clinical research in spinal cord injury. Dr. Sachdeva received his PhD from Drexel University in Philadelphia and completed his postdoctoral training here in Vancouver in Dr. Krassioukov's lab at ICORD and UBC. So without further ado, I will hand over to Rahul to begin his presentation.
Thank you, John. Thank you so much, John and Terry, for this kind introduction and for inviting me for this session. It's really, really an honor for me to be able to talk today in front of such a dynamic audience. Like you said, John, I really enjoyed the last 1 hour of this discussion among all the individuals who have, experienced this technology. And it's really reassuring to know that we are putting our research career towards something so meaningful. So I really thank you all. So the focus of my talk is going to be sort of talking between animal and human models of spinal cord injury. Animal models of spinal cord injury and how we can translate that research into humans. And this will be a focus on cardiovascular function and obviously with neuromodulation. So I would start with my disclosure. So I have some funding sources to thank, Wings for Life Foundation, Department of Defense US, and CIHR. And I also want to make a disclosure that I just started my own lab. So most of the data, in fact, all of the data that I'm going to present today is going to be what I collected or what I worked on in Dr. Krassioukov's lab at ICORD. And I'm also a consultant with a company that you heard just earlier today about is Spinex, which also makes these spinal cord stimulation devices, and it's a for-profit company. Okay, so for the non-scientific audience today, I wanted to just start with sort of giving a refresher on what really is research translation. When we talk about research translation, what it really means. It's basically a multi-step, tedious, long process of turning all our observations in the lab, whether it's a clinic and in community, to finally developing the interventions that have an ultimate goal of improving people's life, people like you and I. So that's the whole overall very broad definition of translation. But if you really break it down, this is what a translational spectrum looks like. It's a continuum. It's going from very basic scientific research all the way towards the community. That's the ultimate goal. But one of the realities of this translational research is that it really costs a lot. It takes a long time and it fails quite often. And one of the reasons why it fails a lot is in this earlier phases. So if you can follow my pointer, in the initial phases where you're translating from basic animal science to humans, initially in clinical trials, this is what our field refers to as the valley of death. This is very commonly used term in the pharmaceutical industries because many of the drugs fail at this stage. And why this fails at this stage is because there are a lot of operational hurdles, which some of them are listed here. We talked about reproducibility earlier in John's talk today, clinical relevance of the research, intellectual issues, regulatory issues, privacy issues, funding issues. There are a lot of operational hurdles which cause a delay in this translation from animal to human implementation eventually. So what does this look like in the field of neuromodulation? So since we're talking about neuromodulation today, so I thought it will be appropriate for me to talk about this in terms of neuromodulation. So what does it look like, the translational spectrum going from animals to humans with the focus on neuromodulation? So this is a unpublished scoping review done by a very brilliant MD student in our lab named Marco Law. And he focused on looking at all the spinal cord stimulation studies published on the PubMed, which were focusing on autonomic recovery. So you can see cardiovascular, bowel, lower urinary tract, and sexual function at the bottom here. So what we did was we looked at animal studies. So this is all we could find on the animal studies on neuromodulation after spinal cord injury and looking at autonomic function only. And it's only total 15 studies in last 50 plus years. So if you go back to my previous slide, when I said the rate limiting step being animal to human translation, if we have such low number of studies in animals, what would you expect in human studies? Would you expect a lot less human studies? Well, luckily for us, that's not the case. We had way more human studies in spinal cord stimulation for autonomic function. This is only specific to autonomic function. If you add motor function, you'll have a lot more here as well. So, and this tells us that we did not really require too many animal studies to come to sort of human implementation of this technology, partly because if you remember from John's presentation earlier, that a lot of research in humans was already done with spinal cord stimulation indicated for some other conditions such as pain. So safety profile was already somewhat established. So if we don't really need that many animal studies to get to human research. Sorry, let me just this is just a more detailed view of all these studies. So you can see there are a lot less studies in almost every function in animals, and we have a lot more in humans. This is just a breakdown of these studies. And what you're seeing here is in the circles is the number of studies. The color of the circle represents the type of stimulation. So green is epidural, black in animals is a direct stimulation where the spinal cord was sort of injected with a microelectrode to stimulate. There were some transspinal studies where the electrode was placed on the fascia above the spinal cord. And there are obviously some blue, which is transcutaneous spinal cord studies. So this sort of showed us that there is a lot more human research already being done, despite a lot less animal studies. So does it mean, do we not need any animal studies? Well, the answer is obviously, yes, we need animal studies. And why do we need that is because we need animal models to understand the pathobiology of the condition or disease, in this case, spinal cord injury. How does spinal cord injury impact the function at cellular, molecular level, for example? And when we're talking about interventions, we need to have a high resolution mechanism of action of those interventions so that we can understand what are the cellular and molecular substrate that at which the spinal cord stimulation is working. And if you remember, Dr. K mentioned there are, even with that small 565 16 electrode device, it has 22 million permutations and combinations of how you can stimulate the spinal cord. You can't obviously do all of that in humans. So we need animal models where we can use large number of tweaking and testing stimulation protocols. And lastly, spinal cord stimulation, it's great, but it's not the only solution. So in future, if we want to add any other treatment modalities with spinal cord stimulation, let's say spinal cord regeneration, for example, we need animal models to study that as well. So the focus of my research is primarily on blood pressure after spinal cord injury. So we talked already about blood pressure. So if you look at 24-hour blood pressure monitoring from an able-bodied individual, it looks something like this. The blood pressure is more or less stable in that 120/80 range. However, if you remember from Bryan, he mentioned that his blood pressure is like a roller coaster. So if you look at somebody with a spinal cord injury, the blood pressure looks a lot wavy, a lot of ups and a lot of downs. And you can see the blood pressure clearly goes beyond the normal range where it should be in a normal, healthy individual. What does it do to end organs? So for example, let's take brain. Brain is one of the most vascularized organs in our body. It makes about 2% of the body mass, but it takes about 20% of the blood supply of the body. Brain is also very smart. With a process called autoregulation, at a wide range of blood pressure, brain can regulate the cerebral blood flow, which you're seeing in y-axis. So the horizontal line stays horizontal across a wide range of changes from 50 to 150 millimeter mercury in the systemic blood pressure. But as you can see in this figure above, this is going way beyond that range of 50/150. So what happens to the brain when, or the brain blood vessels, when the blood pressure in the systemic form is fluctuating way so much? So this is, the higher episodes are called autonomic dysreflexia, and the lower ones are called orthostatic hypotension. And I will talk about autonomic dysreflexia in just a minute. So we obviously need, again, animal models to study what is happening to our brain blood vessels, for example, in case of spinal cord injury that affects cardiovascular control. And in this case, we took rats with spinal cord injury and we isolated their middle cerebral artery. So the artery from their brain, it's one of the largest arteries in the brain. And we mounted them on cannula, which allows us to sort of expose this artery to a number of different conditions, which we cannot study in vivo. So this is what an artery looks like. It's basically a artery out of the animal, but it's still practically living. What we see first is by changing the pressure inside the artery, we check the distensibility in response to just physical pressure. And you can see red is the spinal cord injured rat compared to the blue, which is a control rat. The artery's distensibility is much reduced at higher pressures. This was because of this COL1 is basically a collagen 1 protein, which was almost 50% more in the rats, in the arteries of the rats with spinal cord injury, meaning these arteries were expressing a protein that makes them very fibrotic, very stiff. They're not flexible enough. And similarly, in response to chemical that can dilate the artery, we can see that the dilation in response to a chemical called carbachol, the dilation is also reduced. So this tells us that the arteries are not compliant enough to changes in the fluctuations in the systemic blood pressure. It does affect the cerebral blood flow. So we are looking at the blood flow at a rat, in a rat at rest. This is using MRI. On the left, you can see a lot more blood in the brain at rest in a rat, which is a non-injured rat versus a rat that has a spinal cord injury. You can see a lot less blood. This was total brain blood flow, which was reduced in a rat. And this is brain blood flow in the specific areas associated with memory, for example, hippocampus here. So we wanted to test whether it actually affects cognitive function or memory in this particular case. So we tested this memory function in the rat using novel object recognition tests. So I will show you a small video. So in this, we are looking at a short-term memory of a rat, which is exposed to two similar objects for a long time. So rat is now able to memorize these objects. Then we take away one of the objects and we change it with a novel object. So now they are naturally curious. So they will tend to explore a new object more, provided they remember what the old object was. So this ability to distinguish between new object from an old object we can quantify that by the time spent on the new object, and it's called D-index or discrimination index. And you can see it is impaired after spinal cord injury. So what this tells you is that the rats with spinal cord injury in this case had weaker short-term memory. Okay. Does this happen in humans as well? So we conducted a review while I was in Dr. Krassioukov's lab and looking at a number of questions associated with cognitive functions after spinal cord injury. And one of the things we wanted to look at is, does the dysregulated cardiovascular control affect cognitive function? And indeed, we found a number of studies that talked about humans with spinal cord injury where cardiovascular control, impairment in cardiovascular control was associated with at least some form of cognitive deficit. So we are able to sort of go back and forth between animal models and human studies as well. Just a very brief, I know this is not a very scientific audience, so just a brief overview of why spinal cord injury affects blood pressure control. So our blood pressure is modulated by RVLM, which is rostroventrolateral medulla. It's a small area in the brainstem, which controls the specific neurons within the spinal cord, which you see in the black here and zoomed in into the smaller windows here. These neurons are called sympathetic preganglionic neurons. These are the neurons that actually drive the sympathetic control towards the vasculature from the spinal cord. And if there's a spinal cord injury, as you can see here, these neurons are no longer under control from the brainstem. So what you see is when their tone is lost, a person with spinal cord injury or an animal with spinal cord injury will have low resting blood pressure. They will also have further lower episodes of blood pressure when they are assuming an upright position, which is called orthostatic hypotension. I'm sure many of you are aware of that. It is where the blood vessels are not able to constrict themselves in order to bring the blood back to the upper body when there is a gravity-mediated flow of the blood to the lower body. And then the condition called autonomic dysreflexia, as many of you already know, which is a high blood pressure episode condition, and which is going to be the focus of the rest of my talk. So autonomic dysreflexia, just quickly give you a pathophysiology. It's basically an exaggerated blood pressure response in response to a painful stimulus. So when there is a disrupted control from brainstem, which is here, towards the spinal cord that controls blood pressure, it changes the sympathetic preganglionic neurons that control the blood pressure within the spinal cord. And the pain fibers that are growing after spinal cord injury, what they do now is they relay excessive signals inside the spinal cord that leads to a sort of like a reflex, which leads to vasoconstriction and rise in blood pressure. And it looks something like this. I will talk about this in a minute. And this can be sensed by the brain, but because there is a spinal cord injury, it cannot be sort of inhibited or regulated by the brainstem blood control centers at the blood pressure control centers. So this is a case of an autonomic dysreflexia in an individual with cervical spinal cord injury. who was undergoing penile vibrostimulation for sperm retrieval. And as you can see, every time the vibration was applied, the blood pressure goes up. And at the time of ejaculation, where you see this asterisk, blood pressure almost triples, more than triples. It is commonly observed in individuals with spinal cord injury above T6 because majority of the blood pressure controlling neurons within the spinal cord are now dysregulated when the injury is higher. I don't have to tell this audience about the symptoms, but we talked about headache and flushing just earlier today. And it can happen quite frequently. Our lab has reported as high as even 41 times a day. And this is so frequent because there are a number of triggers that can cause autonomic dysreflexia. Number one being distended bladder, where bladder is full, UTIs, penile vibrostimulation, like I just showed. Fecal impaction, constipation is another cause, but there are a number of other causes that can, on a daily basis, lead to autonomic dysreflexia. Our lab has looked at consequences of autonomic dysreflexia. This was a review done by Dr. K and colleagues few years ago, and they looked at 32 cases of autonomic dysreflexia that had some form of complications. 23 of them had CNS-related complications such as hemorrhage, ischemia, infarction, seizures. 7 of them had cardiovascular complications such as cardiac arrest, arrhythmia, and 7 of these cases resulted in AD-associated death. I can't see my clock. How are we doing with time, John?
You've got 7 minutes left, Rahul.
Okay. Sounds good. So can we modulate the spinal cord cardiovascular circuitry using spinal cord stimulation? So initially studies were using individuals, inviting participants who already had a device implanted in them using epidural stimulation. There were a number of studies, some of them that involved Dr. Krassioukov as well, were published looking at effect of epidural stimulation on modulating blood pressure. But what we wanted to test was whether we can use a non-invasive spinal cord stimulation. So instead of putting an electrode on the dura here, we put an electrode on the skin. And another study looking at EMG activity in muscles also showed that there are common neural structures associated between epidural stimulation versus transcutaneous stimulation. And this is basically EMG signals from different muscles targeted by both of these means of stimulations. And you can see the responses are very similar. The latency, the amplitude, the duration, everything is very similar between the two, suggesting that there are common neural structures that are activated by these two modalities. So we used an animal model to see whether we can use spinal cord stimulation to reduce AD severity. So we did a T3 complete transection. We waited long enough, which is like a chronic stage, about 6 to 7 weeks. And we implanted these wireless telemeters for beat by beat blood pressure measurement. And then we exposed these animals to spinal cord stimulation while modeling for autonomic dysreflexia. We triggered autonomic dysreflexia by inflating a balloon in the rectum, which mimics the clinical relevant fecal impaction, which also is a common cause of AD. And we looked at the changes in blood pressure when the balloon was inflated. And as you can see, when the balloon is inflated, blood pressure goes up, and we can look at this elevated blood pressure, subtract the baseline, and we can calculate the severity of autonomic dysreflexia. And that's when we tested in different preclinical experiments. We tested the efficacy of transcutaneous spinal cord stimulation in mitigating autonomic dysreflexia severity. So in group number one, we looked at the acute effect of spinal cord stimulation. And what you saw, we looked at either prevention of AD or treatment of AD. So in prevention, first we looked at autonomic dysreflexia in the absence of any spinal cord stimulation. As you can see, when the balloon is distended between 2 and 3, we see severe AD. But when the TCS is on prior to instigating the AD episode, we are able to prevent an autonomic dysreflexia episode. And in treatment, we try to trigger the AD episode first, and then during that AD episode, we started the stimulation, and you can see when the stimulation is on, we bring the blood pressure down almost to the baseline levels. So this was acute effect. The 3 lines here, groups 2, 3, and 4, we can see we did the long-term stimulation, very similar to the many of the clinical trials you have been a part of. And we wanted to see, in the absence of real-time stimulation, do we have a long-lasting effect of this stimulation on AD severity? So we looked at 1, 3, and 7 days post the final session of stimulation, either doing an alternate day TCS or a daily TCS. And what we saw was that at all 3 days following the last stimulation session, compared to no TCS in orange here, both the stimulation paradigms resulted in a lower severity of autonomic dysreflexia. So using this animal model, we could use this to show that AD was mitigated. We did this in a human being with spinal cord injury, which was 3 years post-injury, C4-AIS-A. And we did the same, we used the DARS procedure in a rectal stimulation to trigger AD. And this is again prevention. We showed that AD was triggered during DARS, but when TCS is on, AD was mitigated, AD was prevented. And this is just the quantification. When we had AD triggered first, in this case, this is an interruption. As soon as the stimulation starts, the green lightning bolt here, we can bring the blood pressure down. And this is the quantification. So in animals, we can use to study mechanisms. We can use animal models to study mechanisms. And one of the reasons why we think spinal cord stimulation works is using a gate control theory. So what it's basically doing is that gate control theory suggests that you can turn off or interrupt the gates for the painful signal that leads to blood pressure rise in autonomic dysreflexia by starting a new gate using a non-invasive spinal cord stimulation or invasive spinal cord stimulation. Basically, turning this on can shut off the gates for this. So this is the work done by a PhD student in Dr. Krassioukov's lab, who's basically looking at all of these neuronal populations step by step. So first of all, so he's looking at different animal groups. So SCI only, SCI with autonomic dysreflexia, with stimulation alone, and both of them together. And he's looking at different neuronal populations. So for example, this neuron that brings the signal up from the painful stimulus towards the blood pressure controlling neurons. And what you see in red here is that during CRD, these neurons are activated. So red here is a marker for an activated neuron. He's then looking at these SPNs, which are the actual output of spinal cord towards blood pressure control. And he's showing that with this autonomic dysreflexia, you can see those neurons are also being activated. And the final question he's trying to ask is whether the activation of inhibitory neurons using TCS can mitigate autonomic dysreflexia. And again, qualitatively, he's showing 2 different populations of inhibitory neurons. So green here is a marker for inhibitory neurons, and red is again showing activation of those inhibitory neurons, which eventually turn off the gates for this painful stimulus. So finally, my conclusions for today. Individuals with spinal cord injury can present with episodes of hypotension and hypertension within the same day, several times a day, as you saw. These profound changes can have severe effects on end organs. We do need animal studies, which are really, really crucial in understanding the pathobiology and also testing these interventions at an early stage. And neuromodulation is no doubt an emerging technology that can sort of help us treat these dysfunctions, potentially with long-lasting effects. There's a lot that needs to be done. There is a need for a lot more robust studies. This is also from a review from our lab, which looks at the quality of the studies. The higher in this pyramid means the better quality study, and you can see most of the studies are focused on the case series or case reports, with a few being cohort studies, but there are no RCTs, randomized controlled trials right now. And finally, I want to leave you with this figure, which talks about why we need a lot more animal studies, because we need to understand animal mechanisms, underlying mechanisms using these animal studies. So, and I only talked about cardiovascular function today, but obviously, as you all know, there are other autonomic functions, there are other motor functions that also need to be studied. So that is, so there is a lot of things that we need to study in future in terms of neuromodulation for functional recovery after spinal cord injury. With that, I would like to thank my colleagues at Dr. Krassioukov's lab back in Vancouver, all the study participants and their caregivers, and the funding partners. Thank you, and I'll take any questions now if we have time or later.
Thank you. Yeah, we're going to do the Q&A after Dr. K and Dr. Elliott's presentation. So please stick around for that for questions that come through. But yeah, I think, that was a fascinating presentation about the challenges in blood pressure dysregulation and how you can hope to understand more about what's going on inside the bodies of persons with spinal cord injury through looking at animal models. and how that is so vital as we look to translate into treatments for humans. So thank you, Rahul. And I think, whenever I have some cognitive challenges, I always think about the research you guys have done about the challenges of blood pressure fluctuation, of orthostatic hypotension and autonomic dysreflexia, and the blood pressure bouncing up and down continually. And that's how it impacts us. So anyways, without further ado, again, I think I've ado it a few times already. It's my pleasure to introduce Dr. Andrei Krassioukov and Dr. Stacy Elliott. I think you've heard from Andrei a bit already, but just to give you his quick bio, he is a clinician scientist devoted to helping people with spinal cord injury maintain their cardiovascular health and achieve their top priorities in recovery and rehabilitation. It is his goal, through innovative approaches in education and research, to make spinal cord injury preventable, livable, and curable. And I will say, it's not in his bio, this is my personal opinion, he is one of the world's leading experts in autonomic dysfunction after spinal cord injury. And we're so lucky to have him here in Vancouver, and so lucky to have him dedicating his life to helping us. Dr. Stacy Elliott is also a world-class clinician and researcher. She's a clinical professor in the Department of Psychiatry and Neurologic Sciences at the University of British Columbia, and a principal investigator at ICORD. She's the medical director of the BC Centre for Sexual Medicine, co-director of the Vancouver Sperm Retrieval Clinic, and a physician consultant to the GF Strong Sexual Health Rehab Services, and a continuing affiliate of the PCSC program. I'm not sure what that acronym means. And she's also a past chair of the Canadian Male Sexual Health Council. And to be honest, she's just an amazing person. And I think she's probably responsible for more children being born to persons with spinal cord injury than almost any other person on the planet. So thank you guys very much, and I will hand over to you.
Thank you, John. Dr. Stacy Elliott and I are thrilled to be here. We truly enjoyed our first hour of this meeting. It was incredible to hear testimony of individuals with spinal cord injury, with epidural stimulation, with transcutaneous stimulation. That's why within the next hour, what Dr. Elliott and I would like to bring to your attention what we actually have in our hands right now with respect of impact of epidural or transcutaneous stimulation on autonomic dysfunctions. And I was really, truly enjoyed to hear from many patients, from many individuals with spinal cord injury, that autonomic word of autonomic dysfunction is not foreign to anybody. We will present you some interesting data from clinical trials that conducted in my laboratory, and Dr. Stacy Elliott is a crucial part of numerous clinical trials. We talk about some Canadian trials. We will give you some insight what's happening in Ukraine with spinal cord stimulation. And mostly we will focus on definitely what is impact spinal cord stimulation can give person with spinal cord injury on autonomic control. If you look at this picture, you will see a person on a wheelchair, everybody moving, everybody running, everybody rushing. And of course, I'm talking with very highly qualified individuals who have personal experience. What do you believe is the most crucial idea for recovery amongst the mind of people with spinal cord injury? I can say you for many, many years, scientists and clinicians believe we have to cure paralysis. Obviously, paralysis, inability to walk is visible, obvious, person on wheelchair. However, autonomic dysfunctions, which are invisible disability, were for many, many years some kind of poorly understood, poorly investigated, or totally ignored. And I believe today we definitely clearly talk about blood pressure control, sexual dysfunctions, bowel, blood dysfunctions. Sometimes many of our patients don't want to talk about this. Many scientists have no idea what to do with these dysfunctions. And that's why it was quite challenging for me about 30 years ago when I came to North America to start ideas that we have to explore further. autonomic dysfunctions in people with spinal cord injury. What are the issues? What are the problems? And for many years, I heard the problem, Dr. K, it's not a problem. We have to cure paralysis. And as we know at the present time, it's not true. Many individuals with spinal cord injury do care about this invisible disability. It is among their highest priorities. Already Rahul talked wonderfully about abnormal blood pressure control. Ups and downs, it's totally abnormal. It's not within the normal range, which we typically know, 120/80. This is a normal blood pressure data for individuals without spinal cord injury. And what you see here, this is a typical blood pressure recording for 24 hours from one of our participants in our clinical trials. This green line showing the normal blood pressures control. But as you can see, during the day and night, his blood pressure went up and down on various occasions. There was a bowel routine. Blood pressure went up to 180 millimeters of mercury. Then he had a lunch around 12, and blood pressure dropped very low. This is very common in people with spinal cord injuries, that after consuming the food, pasta, a little bit alcohol, blood pressure will go very low. It's called postprandial hypotension. Then urinary bladder distension or retention, as you can see, a King catheter occurred twice a day. Blood pressure went up, autonomic dysreflexia. And this is what we typically see, and Rahul mentions that it could happen up to 40 times per day with the same individuals. And unfortunately, it will not go undetected by our cardiovascular system, by our cerebral blood vessels. This is one of the latest review conducted in court in collaboration with Dr. Craig. We demonstrated that in Canadian population, individuals with spinal cord injury are at incredible increased risk of developing stroke and cardiovascular disease, up to 300% up, because of this unstable, abnormal blood pressure control. And that's what we don't want to see. This is example of case reported from colleagues from Spain. Person with spinal cord injury was well rehabilitated, live in community, developed urinary tract infection, developed autonomic dysreflexia. Blood pressure was very difficult to control, and he developed stroke. You see this white area in his brain. This is a stroke area that he survived, fortunately. But in addition, his spinal cord injury, he also developed disability due to stroke. So this is what we don't want to see in our population with spinal cord injury. We already talked a lot, and John did fantastic presentation and introduction into the spinal cord stimulation. I will just mention few issues. Yes, we have already approved epidural spinal cord stimulation for management pain. So far, we don't have any approved devices for management of any other autonomic motor dysfunctions in people with spinal cord injury with epidural implantation. Transcutaneous stimulation, yes, it is a long established therapy for various disorders. And I will mention to you that just only recently we got a first FDA-approved treatments for transcutaneous stimulation for individuals with spinal cord injury. I will talk about this later. So what are the potential benefits for motor recovery? I will start with motor recovery first. I will present you two patients from my practice. Gentleman number one received epidural stimulation within Dr. David Darrow trial in Minneapolis. I'm collaborating with Dr. Darrow on numerous occasions, and I'm consultant for his clinical trials, looking, of course, on autonomic dysfunctions. This gentleman is 55 years old. He has T8 motor sensory complete spinal cord injury. And at the time of implantation of epidural stimulation, he had no voluntary movement at all below the level of injury. After 24 hours of implantation, you will hear right now his wife asking him to move his lower extremity. That's why there is ongoing low threshold stimulation coming to his spinal cord. But most important, he is voluntarily trying to move his lower extremity. Please look on this video. So what you see here, this is a voluntary activation of his lower extremity motor neurons in the presence of epidural stimulation after 24 hours blood pressure, after 24 hours implantation. That's why he did not underwent any special training. It's just sufficient enough to produce electrical stimulation to the spinal cord, activate the silence pathways that we discussed before. That's why he is definitely discomplete injury. This is actually figures and movies you will see from Mooch trial. And Mooch gave us permission to show these pictures. Mooch participated in one of the ISRT trial. It is the International Spinal Research Trial in my laboratory, supported by UK organization. He underwent transcutaneous non-implantable stimulation. You will hear a voice of Dr. Sochi Samojima, who was postdoctoral fellow in my laboratory. He's right now assistant professor at the Washington State University, just down south. Please watch the first video. Mooch is trying hard to move his legs, no stimulation. So as you can see here, we're recording EMG. There was no EMG activity in his muscles. He was not able to move legs. His level and severity of injury is AISB, motor complete, sensory incomplete. However, after 6 weeks, 30 sessions of transcutaneous spinal cord stimulation, to our surprise, we did not focus on motor recovery. This is what happened. It's not a spasm. It's a voluntary control movement by Mooch. That's why here we definitely can see voluntary control. And what's happening in reality, persons with complete motor injury, AIS A and B, actually were transferred to AISC, motor sensory incomplete injury, as a result of either implantation of epidural stimulator or transcutaneous spinal cord stimulation. I was fortunate to be part of this international multi-center study conducted by Adward. PI of the study was Chet Moritz, Dr. Delfield Fortiev, and then Dr. Grégoire Courtin from Switzerland is he's the head of Adward. We just recently published the results of this multi-center study, which included 60 individuals with spinal cord injury, 11 centers around the world in Nature Medicine. This trial was positive. And what I would like to show you, this is one of the participants in Vancouver. Actually, John, may I tell something?
Yes, please go right ahead.
John Chernesky was one of the participants of this trial as well. So this trial was focused on investigation of transcutaneous spinal cord stimulation on upper extremity functions in people with chronic spinal cord injury, when we do know all functional recovery occurred. There is no more spontaneous recovery possible. You will see the movie of one of our patients. He is 72 years old individuals. I specifically designed this trial for Vancouver site. You know that we have a lot of Japanese restaurants in Vancouver. That's why use chopsticks is a very functional, important tool in Vancouver. That's why this is a specific test in Vancouver. Please look how he can handle chopsticks before stimulation. But he underwent 2 months of every other day training with occupational therapist. No stimulation here. He has difficulties to pick up objects. He has difficulties to control chopsticks. However, this is a trial with spinal cord stimulation. Look at his functioning. He easily can manage chopsticks. He can pick up objects. This was one of the only tests, but in general, all individuals participated in this trial in our site in Vancouver as well in other sites demonstrated dramatical improvement in their hand functions. At the present time, these treatments proposed by UNWORD was approved by FDA for therapy for non-invasive transcutaneous spinal cord stimulation for improvement of upper extremity functions in people with cervical spinal cord injuries. This is the first actually approved FDA treatments presently available in the United States, and hopefully it's soon coming to Canada and around the world. But let's talk about autonomic functions. One of the first studies we conducted in collaboration with Dr. Reggie Edgerton. John already mentioned this brilliant man from Los Angeles. And there was a few Russian collaborators and 2 of my PhD, postdoctoral and PhD students, Dr. Phillips, Dr. Squire, involved in this study. And what we showed that in a person with spinal cord injury who had chronic spinal cord injury, motor sensory complete, with profound orthostatic hypotension, you can see we stand up, blood pressure went down up to the 80/60 millimeters of mercury, extremely low. As soon as we started stimulation, 20, 40, 50 millimeters amperes, we were able to increase blood pressure to the normal level of uninjured individuals. Interestingly, patients involved in this trial demonstrated also cognitive improvement. They said, I can see clearly, I can think clearly, that it was really beneficial from the functional aspects, and it was first documentation of possibility to use spinal cord stimulation to improve cardiovascular control. We also conducted a study with one of our first participants in Canada who went to Thailand and received implantation in Thailand. What you can see here with a tilt table assessment, we conducted blood pressure monitoring and cerebral flow monitoring with stimulation and without stimulation. You see orange lines, first diagram showing blood pressure dropped dramatically, as well as cerebral blood flow dropped dramatically. This typically associated with confusion, lightheadedness, dizziness in many people with spinal cord injury. As soon as we started stimulation, blue lines, you can see we totally normalized arterial blood pressure. Blood pressure maintained normal, cerebral blood flow maintained normal, person feel much better. Dr. Chris West, who is right now associate professor in Okanagan, my former postdoc, and Dr. Phillips, my former postdoc, were part of this study. Dr. Squire and Dr. Phillips moved to Switzerland, and they joined laboratory of Dr. Kartin, and they repeated the study in more elegant way. They added some interesting aspects to spinal cord stimulation, and what you can see here again, blood pressure going down with a tilt up testing. However, as soon we start stimulation or they start stimulation, this is epidural stimulation, and again, specific parameters to specific part of spinal cord, blood pressure going up. You will stop stimulation, blood pressure going down. You will start stimulation, blood pressure going up. Again, the repeated our study before. It was a pleasure to collaborate with Dr. Mathew Walter, who is urologist from Switzerland right now. He returned back to Switzerland from my laboratory. He looked at one of our patients' effect on bowel functions. Today, I believe Mathew and few people mentioned that bowel routines take enormous time, up to 62 hours, minutes. However, with spinal cord stimulation, this is decreased dramatically. It's quicker, it's more comfortable. And this was the first documentation from my laboratory publications that we were able to improve bowel function. This was repeated by numerous laboratories around the world that either epidural or transcutaneous stimulation could improve bowel functions. At this point, I will stop and I will give podium to Dr. Stacy Elliott to talk about sexual functions.
Thank you, Andrei. This is going to be a much simpler talk because we don't have the sophistication to measure sexual function like we do with the other autonomic. But the reason it's so important is because sexual function, along with bladder and bowel, are one of the top 3 of the highest priorities for recovery and quality of life. If we look at Kim Anderson's study of 2004, it was really critical to show that it was the highest priority to people with quadriplegia and with the paraplegia, and second to quadriplegia after hand and arm function. So very, very important, and we have to remember that. So these sexual needs, I think, in terms of autonomic function, are often under prioritized. Everybody's afraid to talk about sex or what to do with sex after spinal cord injury. We've actually got very poor quality and quantity of sexually related rehab services, except in Vancouver. I think we do very well. We just had our 50th anniversary of the sexual health rehab service, which is really unique in Canada. But really, there's a paucity of research and there's very limited and expensive treatments regarding this. So I just want to reconfirm that, yes, temperature control, blood pressure control affects your whole daily life, and certainly in sexual health rehab, it's not just about genital function, it's about your whole body, biopsychosocial body, and how you work. And there's all sorts of healthcare professionals involved, not just physicians and nurses, but OTs and PTs. And we did write a paper about this, which I think is very helpful, especially for healthcare professionals to read. So because it's biopsychosocial, because it's multidisciplinary, we have to remember that just because you fix one thing, for example, make erections better, does not mean that your whole sexual life is improved. It's a very physiological and psychological, body image, self-esteem, etc. It's social and emotional, has to do with your relationship quality. And of course, the physiologic, what can we do about preventing autonomic dysreflexia around sexual activity and preserving sensory, potentially orgasmic potential. All this is very important. So when we look at sexual function, it's in the context of the whole person. And I really want to confirm that, because when we look at research, we are not like taking out one artery and looking at what happens. We're looking at the whole person. So we use this framework, which was adapted by my mentor, Dr. Saz, where we look at sexual drive and interest. We look at functioning abilities such as genital arousal, which would be erections in men, vaginal lubrication, accommodation in women. We look at orgasmic potential, ejaculatory potential. But then we put in the context of, what do you want to do? Is there fertility or contraception issues? What about the factors regarding the condition? Lots of medications affect your sexual function, AD, etc. What about your motor and sensory influences? How can you feel? How can you move? Sexual positioning, things feel good or not good. What about your bladder and bowel incontinence? And what about your sexual self-esteem and how you view yourself in your partnerships? So in sexual rehab, we write these down and then we try to find out some way to help you. Who can we refer you to so that we can help you in all these areas so that you have a better sexual life? But what advances have we learned around neurostimulation? Sorry, I just passed the picture of Dr. K's lab, which has been very helpful, especially some of the PhDs and postdocs. And in the ESTAN trial, which Dr. K mentioned, they did look at all sorts of things, but they did not specifically look at sexual function, except we pulled out some context. And neuromodulation is looking at improvements specifically in, and like I said, this genital arousal. So not just erections and how strong they are, how long they last, but do they last beyond this stimulation? And same with the equivalent for people born with vaginas would be vaginal lubrication. That's the same vasocongestion, and the lubrication stems from that in the vagina, just like the extra blood flow in the erection. Is there changes for males to ejaculation? Is there any changes in the ability to reach or feel that vasocongestion, to feel orgasmic sensations, which again is very different after spinal cord injury, if you can have it at all? And do these changes last only during or after the stimulation? And a big problem is the high blood pressure that occurs with dysreflexia when you have either sexual arousal, and especially with ejaculation and orgasm. So when we looked at female sexual dysfunction, again, we're all born with orgasmic threshold, and spinal cord injury increases that threshold, so it's very hard to achieve. So we looked at whether or not after spinal cord injury, there's definitely decreased genital sensation or maybe no sensation. There's problems with lubrication, problems with sexual desire, and there's decreased orgasmic capacity, and it's much harder to reach orgasm. Dyspareunia is pain with sexual intercourse, so sometimes the pain can't necessarily be felt, but it triggers dysreflexia. And there's decrease in sexual satisfaction and in sexual distress. And what we call a sexual dysfunction is also sort of a physiological problem, but it must cause sexual distress to be labeled as a sexual dysfunction. So when we looked at the epidural stimulation, the ESTAN trial, we did have 5 females in that, and we looked at a certain FSDS, which is a female sexual dysfunction distress scale, and we noticed that the distress was reduced by 40%, even though there was no great change in orgasmic capacity, but they did feel some changes after stimulation, and there was no actual orgasm that occurred, but they felt closer to orgasm, so there was some improvement. Again, this is a very small numbers, very small, objectives that we're looking at, but there was some changes. What about if we look at epidural stimulation on prior studies, there was some improved function, there are stronger, more frequent erections. This has been reported in these earlier studies. In one study, there was a woman that achieved orgasm for the first time since her injury with epidural stimulation. Canada. In Canada. And then Claire Shackleton also wrote about that there was improved sexual function and reduced sexual distress in 3 of these females. So 55% decrease in distress and 13% in overall increase in overall sexual satisfaction. So what are our take-home points with females? Certainly, it's a primary recovery target, and epidural stimulation is a promising treatment for reducing sexual dysfunction and distress in women with severe SCI. And again, we have to remember that this is a holistic approach with a multidisciplinary team. The brain is probably still the biggest sexual organ. So even though we have these changes, it has to be incorporated into your sexual life. Then there's another study that we did that's called Below the Belt. This is again Dr. Krasioukov's study. And we know that it negatively affects, again, the physiological responses and the psychological aspects. So again, if we look at even males, there's decreased genital sensation, desire, erectile impairments, harder to reach or feel orgasm, and certainly ejaculatory disorders, which is the cause of most infertility after spinal cord injury. It's just hard to get the sperm out. That's why we have the Vancouver Sperm Retrieval Clinic, and we've had about 150 babies with that. So, and also in males, there's some decreased sexual satisfaction. So this trial protocol was for transcutaneous stimulation, where they used 60 minutes of optimized stimulation 2 times to 5 times per week for 6 weeks. We had 4 men. You can see that the time since injury and their levels of injuries are marked here. And we used validated scales, which is the IIEF, which is not the best because it's validated for people that are able-bodied. And so we also did some sexual interviews to try to get to the more nuances around this, what's happening. And the questionnaire results really show that the effect of this kind of stimulation did improve. On 3 of the 4 men did improve their erections, and the IAF scores did go up, but we have to remember that the minimal sort of clinical importance, the scale needs to go up by 4, and 2 out of the 4 of them went by 4. So again, small numbers, early trials. So what are the interesting things that we found is what they said. And, here's some of the quotes. I could just be at a store or something and look down and there's an erection, kind of like it was when I was high school, or even just transferring from the chair into the bed and taking my clothes off. I maybe already have an 8 out of or 9 out of 10, which is pretty good. And that was new. Or we would wrap up the session. By the time I got to the elevator at I-Court, I had an erection like almost every time. I would say it lasted for about a half an hour to an hour. So these spontaneous erections and durations of erections were better. Now, some men that have certain levels of injuries are not able to get an erection by sexual thought alone. They must be touched. That's a reflexogenic erection. Yet sometimes in these men, the psychogenic arousal did improve, which is interesting, and also the sexual desire. So the increase in number of erections made their brain think about more sexual activity, and his curiosity was piqued. So the psychogenic part is also very important. So conclusions, again, sexual function, again, is still a very primary recovery target for people. And spinal cord stimulation is a promising treatment for reducing that sexual function in sexual dysfunction in males. And that we may so more aspects of improvement in erectile dysfunction, improve frequency, firmness, and duration. Now, this doesn't happen for everybody. Again, our sample size was small. And the subjective reports support that the potential for the spinal cord stimulation might improve other aspects of sexual health and function, including arousal and desire. So if you feel there's some potential, then it will translate into feeling better, more like a sexual person. And again, to actually do sexual rehab, we need a holistic and multidisciplinary approach. And lastly, I just want to say that there are things that are hands-free technology and mind-controlled technology. This is a RubJoy. This is a type of vibrator stimulator that you can use with your brain. There's implantable peripheral nerve stimulators that will trigger the nerves. There's cybersex, which involves avatar, living your whole sexual life inside an avatar situation and having relationships within that, which is very helpful, not only in the able-bodied, but in the severely disabled. We have some artificial intelligence things that are coming along. The big fear of this, of course, is that you don't live in reality. And we have some mind-controlled vibrators from a different room. You can control sexual stimulation of a partner from a different room, which is very interesting. But just getting back to our neuromodulation, I just want to say, and I'm not going to point to any fingers here, but there was one partner that was especially excited because her husband started getting these erections and basically, excuse my language, but she decided to jump on top of it while it was there. And this was a really big, important part for their relationship. So thank you for listening. And I really would like you to please send any anecdotal or any thoughts you have to my email here. I'll keep it confidential, but we just don't have the data. We don't have the anecdotal evidence except what I've heard for the last 35 years. So if you have anything to say, please email me. Thank you.
I would like to finish with one slide. Dr. Sachdeva already alluded to the potential mechanisms how spinal cord injury spinal cord stimulation actually working in people with spinal cord injury. I just would like you to draw attention to a recent review from our laboratory led by Dr. Samojima and numerous postdoctoral fellows in our laboratory. What we definitely know is that spinal cord stimulation will trigger and activate spinal neurons through the what we call superficial or more deeper, like with epidural stimulation, dorsal root afferents. It will activate eventually sympathetic preganglionic neurons, which are crucial for autonomic functions control. And then they eventually will go to the target organ. Will be it's a blood vessel, will be it's a penile or clitoral circulation, will be it's a temperature control. And this is what, at the present time, in a nutshell, understanding how spinal cord stimulation working in people with spinal cord injury. At the end, I would like to say, first of all, thank you to individuals with spinal cord injury who are brave people to come to my laboratory, to other laboratories around the world, and numerous individuals right now at this meeting who come, ask questions, explore their options. And this is absolutely incredible. Without your participation, research science cannot go ahead. I also, of course, would like to acknowledge help and support and hard work of my postdoctoral fellows, graduate students, clinical coordinators who absolutely important part of the research. Mathew, I was very, listen your descriptions that when you went to Thailand, and I went to Thailand clinic many times and I meet with colleagues in Thailand, you definitely notice they're doing incredible clinical part of their job. Rehabilitation setup is fantastically there, but there is not capacity to do multi-modality assessment that we will do in our clinical trial, which is incredibly important. And then, of course, this will be impossible without support from various clinical research organizations, including Canadian Institute of Health, Cancer Foundation, Praxis. We are fortunate in my laboratory to have grants from Department of Defense, multi-million-dollar grants, Spinal Research Trust in UK, and so on and so on. That's why we are happy to answer your questions. Thank you very much for your attention.
Thank you.
Oh, thank you so much, Dr. K and Dr. Elliott. That was a fantastic presentation. What a wonderful way to wrap up this evening's day one of the SCIBC Neuromodulation Symposium. I have so many questions, and I see Rahul's been busy in the chat answering questions as well, which I think we'll bring forward. But I think the first question should be brought forward by our wonderful host, Terry Thorson. Terry, did you want me to ask the question on your behalf, or did you want to jump in and ask it? So you mentioned earlier about the expedited bowel programs going from an average of about 60 minutes down to 25 minutes. But did you account for bowel accidents? Was there a change at all in the number of accidents that people were experiencing? Because we know bowel programs are a challenge at the best of times, but those unplanned bowel movements that happen at any given time of the day can be a real big challenge as well. So wondering if you guys captured any information on that.
Yes, we actually using Dr. Krogh. Dr. Krogh, Klaus Krogh, is a gastroenterologist and physiatrist from Denmark. We're using his validated neurogenic bowel dysfunction score. But again, John, don't forget, we're still in a process of assessing all these clinical trials. The published report was only on one patient from my laboratory, from laboratory of Dr. DeMarco, from Parag Laboratories. That's why it's still very early data. We do collecting this data. Give us another year.
Sounds good. And I suppose if you've got people with spinal cord injuries that want to share their experiences, perhaps you could capture those as what we call patient-reported outcomes that maybe aren't clinically relevant.
Absolutely. Yeah. Yes, this is a part of our clinical trials as well. That's what Dr. Elliott mentioned. Interview patients, interview is important aspect of outcomes that we are collecting.
It's a brave new world where the thoughts and opinions of people with spinal cord injuries are considered as important as they are now. I don't think it was like that 25 years ago.
So John, I just want to add that, we've been doing PVS, which is penile vibratory stimulation, for many years to collect sperm. And this is anecdotal, okay? But still, those men that are regularly able to ejaculate through PVS, some of them do it weekly, and it helps reduce their spasm. But they also report that their bladder and bowel gets more consistent. And we don't have a study to show that, as far as I know, but I still think it's interesting that sort of once you have this regular discharge, maybe there's something that sets up your sex bladder bowel a little more stable. I'm not sure. It's just an idea to throw out. And again, we'd love to hear from anybody that's experienced that.
So you're encouraging our listeners to experience sexual pleasures on a regular basis. And I think,
Well, just be careful with the dysreflexia. That's why we use the PVS for on Dr. K's studies. So,
absolutely. And the nerves that innervate those parts of the body are so nearby the bowel and bladder nerves as well. So I can imagine that if some of them are getting a bit more attention, then the other ones may wake up a little bit as well, potentially.
Absolutely correct.
Yeah.
And there's also just to mention that Skyer just put out a video about PVS that might be helpful for people that are interested in it. So.
Sounds awesome. If you're not familiar with Skyer, that's spinal cord injury research evidence, and if we get a chance, we'll throw that in the chat so people who aren't familiar with Skyer can find out about it. It's a great resource for anything spinal cord injury related. But I wanted to invite Dr. Sachdeva back into the conversation because there was some questions that Rahul was answering in the chat around that blood pressure instability. Now, I know Dr. K, you did a publication with Aaron Phillips and Chris West on that constant fluctuation of blood pressure, the swinging up and down of blood pressure. One of the questions was, what's worse? Is it the high blood pressure from dysreflexia, the low blood pressure from orthostatic hypotension? Is it a mixture of both? And just how much out of normal levels does your blood pressure need to fluctuate systemically before it starts to cause challenges in your brain?
I can answer that, John. But before I answer that question, I just wanted to add one more comment to your previous question about the bowel episodes. Even though the data is not clearly available about the bowel, but we know from others, including Parag's work on bladder function, that the number of incontinence episodes with bladder are definitely lower with spinal cord stimulation. So that is something he has captured, and I believe he has already published that. So I know it's not the same thing, but still there is some evidence on incontinence related to that. Coming back to your question about blood pressure instability. So as I was answering in the comments, if you remember, I showed the fluctuation, and when you look at the autoregulation curve of the brain, so the brain blood vessels are really smart in a way that they can change the diameter of the lumen diameter, and they can adapt to the systemic blood pressure. So the general range for this, obviously there is a lot of discrepancy about this autoregulation data, but general range is the mean arterial pressure between 50 to 150 millimeter mercury is the range where blood pressure in the brain is sort of stable. And as you saw from Dr. K's traces that he showed and the traces that I showed, that in individuals with spinal cord injury, the blood pressure is constantly going above that range and below that range. And because the blood vessels they have to deal with this change more frequently than what they would in a normal individual, they're also undergoing these fibrotic changes, which is now making them more stiff. So what doesn't bend breaks, basically. So to answer your question specifically about whether higher is bad or lower is bad, I think they're both bad. If it's too high, it can cause hemorrhagic stroke. If it's too low, it can cause ischemic stroke. So I hope that answers your question. And Dr. K, do you want to add anything here?
Both low blood pressure and high blood pressure are bad.
Exactly.
For many years, we believe that only hypertension is a cause of cardiovascular problems in people with spinal cord injury and without spinal cord injury. And during the last decade, we really understood that as well as low blood pressure, what Dr. Sachdeva mentioned, as well as bad as a very high blood pressure. That's why ideally, we would like to keep blood pressure within this green line, which both Rahul and I showed. 120 over 80 is ideal level of blood pressure that we should have during the day, activities, and so on and so on. Yes, during exercise, we will increase blood pressure. It's normal. But it cannot go to 250 to 300 millimeters of mercury. Actually, I will ask question, how many people with spinal cord injury in the audience measured their blood pressure during sexual activities? Anyone? Some did who come to our clinic, to Dr. Stacy Elliott clinic, definitely had blood pressures. But we do know that in able-bodied individuals, blood pressure during sexual activity, sexual act, will increase by about 50 millimeters of mercury. That's why from 120 to 170 for a short period of time. In person with spinal cord injury, it will go up to 300, 350 millimeters of mercury, and for a long time. That's why this is totally abnormal. And that's what we actually were showing, that with spinal cord stimulation, we can actually diminish this abnormal hypertensive crisis episode during sexual activity in people with spinal cord injuries. That's what this is one of the exciting part of our research and clinical trials that we're conducting right now.
Awesome. Well, that's a perfect segue for me to invite our gracious host, Terry Thorson, to jump into the conversation.
So interesting. This is a great segue, because I actually decided to be a part of one of Dr. K's and Dr. Elliott's studies on sexual health and orgasm and dysreflexia. So it was really interesting because with transcutaneous stimulation, my dysreflexia when I was stimulated sexually was much less. So with stimulation, I'm pretty sure, Stace, I don't remember, but I'm sure it went up to like 300, my blood pressure. It was ridiculous. And it was still high with the stimulation on, but it wasn't certainly as bad. So I thought that was, and not as uncomfortable, so to speak.
So you notice the symptoms were much less pronounced as well.
So not only is the physiological
blood pressure, yes,
but also the symptoms the person is feeling.
Yeah.
I wonder, we've got a great audience here that's been very active throughout the entire session. Does anybody in the audience want to jump in? I see Mooj, you've got a question around nitric oxide levels. Did you want to jump into the conversation and ask Dr. Elliott and Dr. Krassioukov and Dr. Sachdeva your question?
Sure, yeah. So the reason I'm asking that is it seems like one of the main results from the transcutaneous stimulation is more frequent erections. And so I'm just curious if that could be psychogenic, or if there's an actual increase in the nitric oxide levels in the genital area of people's spinal cord injuries with stimulation.
So the nitric oxide is a gas, right? And the nitric oxide comes from the nerve endings, but it also comes from your endothelial lining. So if you have stimulation of the nerves, it makes sense that there might be a bit more nitric oxide, which is what relaxes the smooth muscle and allows your blood flow to occur for erections. But it could also just be from direct nerve stimulation, and you can chime in here, but I think it's the same with the bladder and bowel. So yes, there might be more nitric oxide release, but I would hope that the nitric oxide, again, it's a gas and it'll dissipate once it's done its smooth muscle relaxation. So how Viagra, Levitra, all those drugs work is by restricting an enzyme that will ultimately destroy the nitric oxide. So they keep the nitric oxide around a bit more. I don't think that's how the stimulation is working. I think it's a direct nerve stimulation waking up, which may release more nitric oxide, but it's very hard to actually measure that. That's a job for Rahul and his little rats because you can't do that in humans. And there's supplements on the market for guys that weight lift that increases their nitric oxide. It's impossible. Okay, it's a gas. So First of all, don't take any of those. It's a waste of money. But I maybe Andrei can comment on the reason that I think that the erections are better is you're directly stimulating that nerve. Just like if you do an implantable device around the prostate and stimulate those nerves, the dorsal nerve, you're going to create an erection.
So is there a difference in so between psychogenic and reflexive erections? Do you know if the stimulation is increasing them separately, or can the stimulation just be increasing autonomic erections?
So the reflexogenic erections are the ingoing and outgoing reflex nerves, right? Which I think definitely is happening with the lower stimulation. But if you have an incomplete injury and your mind is stimulated and you're thinking, wow, I'm feeling something is happening here, if those remaining nerves will send down a message from the brain saying, go for it, right? So I think that there is some psychogenic potential. But if you have, a lower motor, like a low injury, then you're really reliant on those psychogenic signals transmitting that nerve. Whereas if you have a high level injury, those psychogenic signals are not very strong, right? So you're reliant on your reflexogenic erection. So I don't think the stimulation per se is changing one from psychogenic to reflexogenic, except through that biopsychosocial model, right? Where you think, oh, wow, things are better, you feel better. And if there's some remaining nerves from the brain to the genitalia, that will enhance that. Does that make sense?
Yes, yeah, that makes sense. Thank you.
Snowballs. Once
I have a question here that what parameters specifically could improve sexual function, I see. That's the present stimulators that we have, we're using the same frequency. And until we were published, I cannot tell you which one. But what is important that we have to find this combination of electrodes. In the first part of today evening, our participants with various clinical trials talk about mapping, positioning of electrodes. So this is, I believe, what we believe most important to find combination, which electrode, which location of electrodes could improve bladder, bowel, sex, or motor function. That's why this is coming from publication soon.
Yeah, I think there's some school of thought that changing the frequency can make a big change. I think some people are suggesting that higher frequencies are better for autonomic functions when it comes to transcutaneous, but we'll look forward to seeing your paper. We've got a couple more questions that are coming through. We've only got a few minutes left here, so maybe I think Olivia has had quite a few questions here, so maybe Terry, can you unmute and pin Olivia, and maybe we'll see if she can get a question in.
Hi guys, sorry, I've been just typing away, I guess. I'm just wondering how this would work for people that are under T6 and I think they don't get AD. It's under T6 that you don't get AD. Anyways, I'm just wondering how this would work, or whether it works the same way.
Is that in terms of blood pressure regulation or an autonomic function in general?
I think a little bit of both.
Yeah, that's right. There is also Megan asked question exactly very similar. That's what is about bladder bowel functions for people who don't have AD. That's right. Circuits which we're activating with spinal cord stimulation, it is focused on lumbosacral area of spinal cord. This area is controlled bowel, bladder, sex. That's why if we will not affect blood pressure, we still will have potentials to improve bowel, bladder, and sexual functions. But definitely, if you don't have AD, thanks God, don't worry. Let's focus on bowel, bladder functions.
I agree.
Awesome, thank you. At the same time, AD can also be useful to kind of know when there's like anything going on that's below a level of injury, where people that are below T6 might not be getting those messages. And I don't really know. That was one of the questions that actually popped up in one of my coaching meetings, because they don't have that signal that tells them what's going on below their level of injury, where us that have AD, yeah, we have to learn how to manage it, but it also is a signal that something's going on below level. So it's kind of useful and not useful at the same time.
You're 100% correct. That's in many of my lectures and actually in many of my papers, I will say autonomic dysreflexia is a blessing and a curse. It will alert you something wrong. But then when it's silent, it is a bad. You're absolutely correct. Absolutely correct.
Anyways, thank you so much for your presentation and for your knowledge. It's been really, really enlightening.
Pleasure.
It's a great privilege to have Dr. Elliott and Dr. Krassioukov here doing such great work. We got a couple minutes left. I'm gonna see if we can squeeze in one last question. I see Gabriel Harris has a quick question. Gabe, are you able to unmute yourself and turn your camera on so you can ask your question?
Yeah, hi there. One of my questions was, is there been any trials done on higher level quads?
Yes. That's one of the trials that we did with the cervical spinal cord stimulation. It was on a hand function, but only, unfortunately, these individuals has to have spontaneous breathing. Right now, we are exploring options of cervical spinal cord epidural implantation to look on cardiovascular or other functions. But to my knowledge, not yet any clinical trials were planned for high cervical people with ventilated support.
So, Dr. K, I think the Onward device has been approved for use up to level C2, if I remember correctly. Now,
correct, but not yet clinical trials started.
Gotcha. And then, you know, the phrenic nerve, if I remember correctly, is the one that innervates the diaphragmatic muscles. How do you feel, you know, with spinal cord stimulation and respiratory function? I know there's some talk about for, you know, people with lower level injuries, it can improve their core stability and their sort of abdominal muscles, their intercostal muscles, their rib muscles. But what about that phrenic nerve denervation that may happen with higher level injuries that may make people reliant on mechanical supports for breathing? Do you think that spinal cord stimulation may have any benefit in that group?
If there is no connections between the phrenic neurons to the diaphragm, we have to implant diaphragmic pacemakers. That's why then electrodes has to be put on the muscle itself. This is reality.
Interesting.
And this is what is done at the present time.
Yeah. All right. Well, what an amazing day one. I think I'll hand back to Terry for a little bit of a wrap up.
All right. Well, this was a full and jam-packed and very informative session. So I just want to really thank everybody, really especially you, John. Like, really thank you so much for your expertise and taking this on for me. And Stace and Andrei, Dr. K, thank you so much, Rahul, and all of our PLEX panelists that were on. I'm sure John will do a big thank you at the end. But let me first go over our day 2 agenda. I'm not going to read it all out, but and that's it. I'm going to pass it on to you, John, for just final thoughts.
Awesome. Thanks so much, Terry. And I concur. What a wonderful session from the very beginning right through. Such great speakers, such great panelists, and such great audience. You know, the interactivity from the audience, all the questions, thoughts. It's just been absolutely tremendous. Thank you all so much for joining and taking part. And I'm gonna have a glass of wine. No, another glass of wine.
Enjoy your evening. Thanks for spending your dinner with us. I appreciate it.
My pleasure.
Bye-bye, everybody. Thank you.
Bye, everyone.
Bye.